Hello everyone! How is everyone doing? Wow, what a group of friends today. What a great group of friends and what a great afternoon. I'm so happy to be here today. Today we are talking about a really cool topic and I'm bringing my fiber friends, my optics friends, my medical friends, everyone together to do business. Ladies and gentlemen, welcome. Welcome to the number 28 of the EPIC Online Technology Meetings. Wednesday, 17th of June, the EPIC Online Technology Meetings continue and the topic of discussion is endoscopy. There is a growing interest in our online discussions about the use of photonics to assist surgeons to make more accurate, successful operations. Improved endoscopy cameras help them identify the tumors from the healthy cells. But surgeons like Stefano Regucci are asking industry to do more.
What is our problem is in the planning of the treatment and problem in the monitoring. How to know exactly the temperature around the lesion, inside the lesion, and outside near the rectum is a bigger problem.
Getting highly accurate temperature readings and haptic feedback from the needle will make for better decisions. What role will new photonic products play in meeting growing demands for speed and lower cost from the health sector? Can we develop the right fiber optic modules and light guide based on micro-optics to add all the functionality needed by surgeons like imaging, OCT, while monitoring temperature and strain? And beyond that, can robots use that to help surgeons to perform operations that have been impossible to date? Just some of the topics to be discussed in a special EPIC online meeting on future developments in endoscopy. Sign up to participate in Zoom or follow us live in YouTube. Add Wednesday, June 17th, 3 p.m. Central European Time to your medical agenda. It is really, truly an epic afternoon today. It is really the moment to start to put everyone together and make sure that all of us can do business. And before we get the ball rolling with the fantastic group of people that we have today here, I would like just to tell you a couple of things. The first one, as I said before, this is really honestly a great pleasure to be here. The idea of after already 28 meetings, keep getting the input and the interest that we're getting from the industry. It was all started on the 1st of April. I was flying back from San Diego. The whole world was falling apart. Everybody was really totally crazy about what was going to happen. And we came up with the idea of actually making online meetings. And now we are overwhelmed by the feedback that we are receiving, and mostly also overwhelmed by the amount of companies that are asking us, okay, you guys from EPIC, you seem to be really hardworking, maybe a bit crazy as well. So I want to join. I would like to say that now we are 570 members. I would like to give my welcome to IMASENIC. They actually make self-cleaning optics, especially for the LiDAR and other segments. And now we have 570 members. We can do totally crazy things. Ridiculously crazy things. I'm going to actually, on the 24th of June, I'm going to moderate a photonics conference for 24 hours straight. 72 speakers. I'm going to start with the speaker in New Zealand. I'm going to finish with the speaker in California. Actually, I'm finishing with Brandon Collins, CTO of Lumentum, and with Bernard Kress from Microsoft. So the idea is really to bring the top people in the industry over 24 hours that will be awake and hopefully alive. And I would like to thank all of you who are sending me all these toys, gadgets, all these beautiful mugs. It's so great to have the support of the industry. I am really overwhelmed by how the photonic companies are liking what EPIC is doing. And also would like to tell you that the whole world is going little by little to what they call the new normal. I'm going to start traveling actually next week. So it's almost then normal. But so we are going very strong with the EPIC meetings on Q4. Actually, we have a really fantastic meeting at Philips for the manufacturing of medical devices in the first week of December, 8 and 9 of December. So I would like to see all of you in Eindhoven or the medical device meeting at Philips. And also would like to remind you that all of you have access to a long list of market reports. We have 17,000 view graphs and collecting market data for you. All of you have free access to this, so make sure that you use it, that you have used it, because we paid a lot of money for this. I would actually like to highlight that we bought at the end of last year a market report from Joel about wafer level optics, and it has a whole section about endoscopy cameras and what is the future towards the integration of micro-optics at the tip of the fiber. Actually, quite interesting part of the market report. Also, we have a great website to find jobs, jobsinphotonics.com. So anybody who's watching this and is looking for a job in photonics, look no further, jobsinphotonics.com. And that's it. Let's talk about endoscopy today. What a great topic to talk about this afternoon. We have to thank the sponsors. We are so happy to have the support of 3 EPIC members today sponsoring this event. Actar Advanced Coatings. If you're looking for a company to develop any kind of filter coating for any application, look no further. These guys are really great on manufacturing customized coating solutions, also in the large volume. HOYA is the key company that we have in EPIC on the filter manufacturing, on the high-end optics, filter-based high-end optics. The idea is that they want to help every company in EPIC to manufacture the right solution by adding the functionality device by their filters. And Technobis Group, thank you all the way from beautiful Netherlands. Technobis Group is a great company for manufacturing fiber sensors, but at the same time, they actually managed to set up a company for packaging photonic integrated circuits for any other application. So you're looking for a partner to package your chips. Technobis Group in Almelo. If you're looking for a partner to help you making a fiber sensor system, Technobis Group in Almelo. That was what I wanted to tell you, because now I want to give the floor to the most amazing person in this room. Her name is Dr. Amairi-Pyka, and I am really, really happy of being her colleague.
Thank you so much for this very nice introduction, Jose. And you know, we have a very nice list of speakers today, as you can see on the screen. But what's really interesting is the amount of people that were very interested in this meeting and the people that are in the room that we participate today. So, of course, the event this meeting is about endoscopy. So we have here one of the biggest players in the endoscope manufacturers and kettle manufacturers. We have Micah from Sign Vivo, who just joined, and we will have joining a bit later Olympus and Richard Wolf, and EndoPhotonics, of course. And we have what you see here are the logos of all the people who registered and showed interest will be following us either in the room or on YouTube. So we will look at all the supply chain. We try to gather all the market players in the field, and we have from the specialized in fiber industry. So we will hear from Photonics, GLOphotonics, NKT Photonics, and we have very interested in the meeting. We have also in the room OFS and Lioni, and we will hear from people specialized in the camera manufacturing, Balza and Ametek, and from the automated production, LED illumination, CMOS sensors. So for the we will hear today from IMASENIC, sorry, and the first sensor, and we have also the part where there is the research and development for endoscopy. We will, of course, pay a lot of attention to micro-optics manufacturing. We have in the room SUS Micro-Optics and Nanoscribe, and we will hear from Multiphoton Optics and FISBA, and we will also have also optics manufacturer, filters, coatings, and photonics assembly, PICS manufacturers, fiber sensors. We have very rich meeting today, and we also will hear from high precision 3D printing and positioning. All this is very interesting for the meeting today. So all these are HOYA, optics, Balza for coating. We will hear from, we have in the room ACM as one of the big players in the field as well. So I'm very excited about the meeting coming today. And we also had the help of the medical market intelligence and the consultants GBF strategy. Jose, some people think we forgot their logos. Is this true?
We never forget any logos. We never really forget any logos. Every company that is here in this rollup with the 570 members of EPIC is always in our head. This slide represents the companies who register for this meeting. So if anybody is like worried, oh, my logo wasn't there, EPIC forgot about me. don't worry, we will never ever forget about you, but please register for the meetings that are interesting for you. Sana is so excited. She told me this morning, I could not sleep last night. This is really the topic that I was waiting for. I would like to let you know that we are streaming this meeting in YouTube. So I would like to say hello now. Hello, YouTube universe. All of you who are watching this, if you want to get in touch with any of the speakers today or participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com. Also, this is valid for the people in the Zoom room. If you want to get in touch with any of the other participants today, of course, you can chat privately with them during the meeting, but if you want to get in touch afterwards, all you have to do is send me an email, jose.pozo@epic-asoc.com. And once again, ACTAR, Coatings, HOYA, and Technobis Group, you guys rock. Thank you very much for sponsoring this amazing, amazing meeting today. We have 2.5 hours in front of us for all of us here to find potential partners, customers, and suppliers. So let's get the ball rolling, and there is no better way of starting this meeting than with the person who really holds the EPIC flag all the way up, talking about collaborating for any solution that requires specialty fiber for in vivo imaging. I'm referring to Photonics. I'm referring to Slava Artyushenko. Slava, thank you very much for being with us this beautiful afternoon. At least the sun is shining here in the Netherlands. I don't know how it is in Berlin. The floor and the attention of everyone goes to your specialty fibers, goes to you.
Thank you, Jose. Thanks a lot. We have 29 degrees in Berlin, so everything is great, real summer. So I hope that everybody has good feelings that Corona will go out and all of us will be healthy and doing really interesting job together. Just to ask if my screen is working now.
It's crystal clear.
Yeah, great. Okay, I couldn't say that we are really a company producing endoscopes, but we are in the field of specialty fiber optics for the whole my life. And company exists for 22 years, and we are able to provide any kind of fiber optics in very broad range from 0.3, from 300 nanometers up to 16 microns, which can be used in the endoscopes. So that's why I will talk a bit not only about our products, but also about products of our, just a moment, how to, I could not.
Just use the space bar. Normally, there you go.
Yeah, okay, over here. Okay, here. So I would like to, provide a review not only about our products, but also about our colleagues. And SCHOTT is one of the most famous company doing a lot of lighting and imaging bundles and even endoscopes. And I was really surprised, and it was really a pleasant surprise with a new product announced during the Photonics West recently. It's kind of the very first single-use endoscope shown at SCHOTT booth, with idea that you have lighting with the fibers, but in the middle you have a tiny camera with very broad angle of viewing, and in result you can really do something for each patient with minimum risk of contamination, because it's disposable endoscopes and each one is about $500. And just to add that in general, endoscopy compared to laser technology is a real big part of biophotonics market in general. Roughly speaking, 2, if not 3 times bigger than the whole market for laser products. Again, not from us, but we are already involved in this kind of method. You see that the classic endoscope is normally a bundle of many fibers in coherent position. And in result, you have a lighting source, you have a working channel for instruments, you have a imaging bundle. But inevitably, you are limited by diameter, because when you try to put 10,000 fibers in, very thin fibers, soft glass fiber, it's still relatively big diameter, like that approximately. And you can replace it. Idea was published in '93. you can really do it with a single fiber and then only illuminate it around, and then diameter can be much smaller. You can bend it for a very small radius. And idea is to use a single mode fiber like here, where you can really move the end, distal end of the fiber with a scanner. And in result, you know, this a chance, you know, to get the quality of the build of the picture from endoscope. Just compare. This is classic endoscope with relatively big diameter, and this is this kind of scanning fiber endoscope, which is used for fluorescence. So that's why you do not have sacrifice of the image quality. Our role in this kind of very interesting endoscope market or technologies is to provide any kind of fiber which is needed for example, for fluorescence, but excited in UV. So we used silica fibers for UV. With silica fibers, we can go up to 2.2 microns. But then, you know, of course, we are more or less limited because it's a fundamental absorption in silica glass. Same time, we quite often have a request to provide metal-coated fiber, because when you have a bundle, then for laser fluorescence, metal-coated fiber will prevent an image from so-called crosstalk, or let's say signal you measure for fluorescence. Plus, it's more flexible, it's very thin coating, while for mid-infrared, we have really unique fibers. It's a chalcogenide glass and polycrystalline fibers. And polycrystalline fiber can be really used for very small radius. Right now, we have fibers from 300 micron produced by regular way and up to 1 millimeter. But you see here, it's a 1 millimeter fiber. You can bend it like this. You can make a knot. Unusual fiber made from silver halide crystals with polycrystalline structure. Grain size is less than what this is 1 micron. So it's about 10 to 100 nanometers each grain size. So extremely flexible, non-toxic, and can work at good temperatures. Sorry. Okay. Advantage of these mid-infrared fibers is in their excellent overlap with illumination from black body. You all probably know that at room temperature, or let's say a bit higher, maximum of emissivity is about 10 microns. And our fibers is transparent in the range from 4 to 16 microns. So exactly in the field where we can measure temperature. So single channel can be very simple. It's a coupling with mid-infrared fiber of single detector. In this case, it can be a thermopile, it can be pyro detector. It can be dual sensor, you know, to compare temperature in different points with a precision better than 0.1 degree. It can be a bundle. Here you see a picture from a relatively big bundle, 9 to 9 fibers. Here you can see even the infrared camera from company Optris. And our fiber optic bundle based on hexagonal package of 19 fibers. So it was just control of quality. So it was really homogeneous in this case. It can be any geometry. For the bundle we assemble for mid-infrared. Because if today endoscopy market on the planet is about 40 billions, just imagine if it will be only 1% endoscopes made specially for mid-infrared, just to see cancer on the stomach wall, because cancer is half a degree warmer. Then 1% from 40 billions, it's something like $500 million for the future. So infrared transmission is great future for infrared endoscopes. And what we already started and do really intensively within the last 6 years, you know, we have tests of tissue in touch, you know, to distinguish malignant tissue and normal tissue. And we really found years ago, it's about almost 30 years ago, that there is, of course, a difference. So, for example, tumor has more glucose, like a biomarker, compared to the normal tissue. We saw it also for stomach. It's quite different spectra. So it means we can provide to the endoscopy surgery an instrument which will give, which will provide to the doctor a chance to differentiate cancer from normal tissue in endoscopic mode. In this case, of course, our fiber optic probe must be very tiny and go through the channel. Here I can give you a sample of how it's done, not for mid-infrared, it's done for Raman spectroscopy by excellent team in Singapore. Dr. Zhiwei Huang, Professor Ho, they already made more than 3,000 endoscopic operations where through the gastroscope, you can see here, they used Raman probe. This Raman probe is about 1.8 millimeter in diameter, and just by touch to the rectum wall, they can really distinguish cancer, non-cancer in vivo. So that's why I'm sure that this kind of future is coming to many clinics in the future. We must really work hard for it. Our part of work, we are able to make special bundles for it and even some first prototypes of these probes of very small diameter. Our approach for this method is not only limited to mid-infrared or Raman. We really have a system for all methods, fluorescence, near-infrared, FTIR, and Raman, all of them on wheels, and we simply move it to the operational room and able to make in ex vivo or in vivo tests of the tissue. So I think I used my 6 minutes, more than 6, sorry, but that's why if you have any interest, you know, to expand your spectra of application in endoscopy from UV to mid-infrared, we are happy to be a partner, vendor, and help you with these solutions. Thank you.
Thank you so much for the impressive work. I actually visited your labs and you have an extremely nice facility, very nice research facility, and very nice work you're doing there. But you know how it goes with EPIC, right? You present what you can do, and you have also to tell us what can the others do for you. These are the EPIC questions.
Yeah, I should say what I probably should show again with the slides, where we really looking for a partner. Look, infrared fibers, when they're in bundle, it's still a relatively bulky bundle. And our dream, and we have a project right now, one European project with partners in Belgium, when this silica fiber, this idea was already published in 2010 or invented even before, but we replace it for chalcogenide fiber or single mode infrared fiber. That's why we can look for infrared image inside esophagus, rectum, what else, stomach. We are looking for partners who can really help us with this kind of scanners, very tiny scanners. So, and I remember one of the first EPIC meeting was with a company for imaging, infrared imaging. It was one company who already mentioned it, and I really blame myself that we did not connect it yet. But this is one of the partners where we are looking for the system solution together.
I think Jose will help you with that. It's never lost. We have also a lot of questions for you. Let me start with the first. Yeah, let me start with the first question from SUS Micro Optics. Wilfred.
Yeah, I see one from Noel. This numerical aperture. I mean, in chat. Or what?
Yeah. Yes.
They will all answer. They will all ask you like this.
Yeah. Okay. Numerical aperture of MIR fibers. Really, it's relatively high numerical aperture for standard composition of coin cladding. So it's about 0.25, 0.3. But we have also chalcogenide fibers for shorter range of for shorter wavelengths between 1 and 6 microns, and then it can be single mode. So really like 10, 20 microns only, and then numerical aperture is of course dramatically reduced. Plus, recently we started, I was afraid to make too long presentation. We started to make hollow waveguides. And now we couple quantum cascade lasers with our PIR fibers, chalcogenide fibers, and hollow waveguides. Hollow waveguides is for smaller numerical aperture. For medical diagnostics, it can be even used for the exhalation composition control analysis to check, to distinguish corona patient from the, let's say, normal person. So that's why very interesting topic. But look for the previous EPIC meeting on medical lasers. It was more data about QCL.
Okay.
It's on tube available. Yeah.
Excellent. My next question is from GF Machining Solutions. We have Hozang.
Yeah.
Yeah. You raised your hand for a question. Can you introduce yourself?
What is the most difficult to make this optic in your side? Difficulties. As I'm a manufacturing system integrator, what is the difficulty to make it this kind of optic?
Very good question. Very good. Really, how to say, sometimes I'm almost crying because we are, for the whole life, we are B2B guys. We produce and develop excellent components. But if you will produce excellent engine, for the car, and it will be no car manufacturer, it will not help to the driver. So that's why we really need system integrators as much as possible, and more of it, not only system integrator who understands which killer application is really needed, what for. So my vision today, for example, I'm really, how to say, pioneering mid-infrared fiber optics, silver halide fibers. We see three niches. It can be laser power delivery. We can deliver any light from CO, CO2 laser, QCL, OPPO lasers, continuous fiber lasers in this range. But this is relatively small niche, I should say, for the volume of the market. Spectroscopy in mid-infrared, excellent market, but then we produce it for FTIR manufacturers, for QCL manufacturers, but again, it should be a sensor which helps to the surgeon to distinguish, let's say, cancer from normal tissue. Who is a customer? System integrator, Philips Medical, Siemens Medical, but with these big companies, it's difficult. It's good to have, how to say, medium-sized system integrator with whom we will be happy to work together to develop excellent product. And infrared endoscope, topic of our meeting today. I think infrared will be the...
It's good. It's good enough. Yep. Thank you.
Thank you so much.
No, don't let him go so easy, because it's so great that GF introduced himself as a system integrator. We have everything that you need here, from optics to specialty fiber to packaging solutions. In a meeting on endoscopy, what is your shopping list? What is your Santa Claus Christmas list? What did you come here looking for from GF?
So actually, I would first of all, I would like to understand about some medical business, because we are not involved into this business at all. But we are slowly get into this business with my part is laser application, but specialized in the glass and also some photo some silicone application. That's why I would like to involve some more business together with the medical business. And first of all, I have to understand about what you are thinking and what you are wish to go. And then maybe I would like to provide some more better application and solution.
Fantastic. At the end of the meeting, I'm going to come back to you to see if you found out exactly what you were looking for.
I'm only the application engineer
well
in the GF machining solution.
Well, I'm really interested if we shall really find one of the very first project to develop.
Of course. Consider it done. I would like to remind anyone who wants to be introduced to anyone today, just send me an email. I love making those introductions. Slava, you told me about the infrared spectrometer solution at the previous meeting. I think we were referring to Skin Vivo, and Mike is here. Mike, goedemiddag. How are you doing today?
Yeah, great. Thanks. Good to be part of this meeting again.
Did you see Slava's presentation? What kind of things can you do together?
Yeah, I think it would be interesting to discuss once to see what is possible, because as you might remember, we developed optical coherence tomography catheters for bladder cancer diagnostics based on these fast scanning MEMS mirrors. And I think in the previous meeting on in vivo imaging, we indeed briefly talked about how that, there might be a match, because we're of course both trying to diagnose cancer more accurately and improve the life of patients in that sense. So I think it would be good to indeed talk once a bit longer to see where the match might be here.
Yeah, I'm really happy to see you again, because sorry, after the meeting, we have so many things to do, but we have really kind of unique components, because your scanner and our fiber, okay, the rest is relatively simple, because, for example, we have excellent collaboration with infrared detectors manufacturers. So infrared detector, pure fiber pigtail, must go into this kind of endoscope with your scanner, and
Yes.
then we have a chances to look inside human body and really do very interesting things. So right now I will try to write in chat, you see my email already. If you send me on my slides.
Jose can make this for you. Jose will make this for you. He will write one email to connect you both. It's going to be easy for you. Don't worry about it.
And then we can talk on this in a Zoom call separately later this week or next week, maybe.
Excellent.
Yeah, I prefer to make not a binary weapon, but binary, let's say, bilateral collaboration, which will really bring a lot of benefit, for the customers. Thank you.
Okay, the meeting is starting very successful, I see. Okay, please let me introduce the next speaker from NKT Photonics, Kim. How are you doing? We're looking forward to your talk.
Well, I will share my screen here and get going. So now we just heard about some excellent fibers from Photonics. So I'm here to give you a little bit of inspiration for a bit of light to put into these great fibers. So I'm here to talk about supercontinuum white light lasers for endoscopy. Very quickly, for those of you who are not familiar with NKT Photonics, we are a supplier of fiber-based lasers and sensing systems. We are headquartered here in Denmark, so actually not far away from Delta and Henrik and DTU, actually. We're around 400 people globally, around a number of sites, and we have a turnover of roughly 75 million euros in 2019. Our main markets are medical and life science, so very, very relevant for what we're talking about today. But we are also have a big presence in industrial and scientific, and we are also in aerospace and defense. In terms of products, we are really a laser house first and foremost. One of our flagships are the white light lasers that we're going to talk about today. But we are also big in single frequency lasers, so very narrow line width lasers for primarily remote sensing and quantum optics and things like that. Ultra fast lasers, both for biomedical applications, imaging applications, ophthalmology, but also industrial applications. And then finally, fiber sensing systems, mainly DTS, so temperature sensing systems, and then of course photonic crystal fibers, which is really where all of this came from. So supercontinuum white light lasers, this is really a special category of lasers. They are pulsed, they're single mode, and they have a spectral coverage which is very close to that of a lamp. Typically, we have a coverage from 390 nanometers, so into the UV, well above 2.4 microns in the same spectrum. We do actually also, now that I got inspired by the IR fibers here, we actually do have systems that operate up in the 2, 3, 4 micron range also. But the typically ones are in the 390 to 2400 nanometer range. They're very high brightness systems since they are lasers. So the brightness is many orders of magnitude above that of, for instance, lamps and LEDs. And since they are inherent fiber systems, it is a fiber delivered output with typically a collimator or just a fiber that you can splice into a system. The fact that this is an all fiber system also makes this fairly robust. We routinely drive these things around in the back of our cars in pillowcases. And you can basically drive around the country for months with these things, take them out of the pillowcase, turn them on, and they will be perfectly fine. So very, very robust. Lifetime is also long. We typically say more than 10,000 hours, and at that time, it's actually not the optics you'll see any issues with. That will just be general electronics degradation and things like that failing. So, but the optics is extremely long-lived. Cost of these systems, something that people typically avoid talking about, but I think this is important to give some perspective. We are typically on the order of somewhere between 5 to 50,000 euros, depending on how much power, what kind of spectral coverage, and what kind of bells and whistles, and how many one of them. So imaging techniques where Super K lasers are used. I've picked just a few ones here that I thought would be relevant for endoscopy, at least some of the work that we have been doing on this. One of the big ones are, of course, OCT. This is already an established technology in cardiovascular and gastro endoscopy. And the Super K super continuum lasers here delivers more power and a lot of bandwidth that gives a good tissue penetration, and it gives a very, very high actual resolution. So if you have spectrometers that are broad enough, and that's a shout out to the spectrometer guys here. If you have a spectrometer that's broad enough, you can get down to micron or maybe even sub-micron resolution with these light sources. And here there's a picture here under there from the Turner Labs in Boston, who we're working with. Confocal imaging and various types of scanning imaging techniques is of course highly relevant for these. We do sell a lot of these into Leica microsystems, using them in their high-end microscopes. And you can of course do this with or without the fluorescence. And then this is also highly relevant for confocal imagings in endoscopic probes. Because this is not only a visible light source, it actually goes way into the near infrared. There's various types of NIR spectroscopy methods that are relevant with this light source. You can also do hyperspectral imaging. And when you are into these wavelength ranges, you get deeper tissue penetration, and you can pull out a lot of information that's not possible if you only work in the visible range. Finally, various types of diffuse optical spectroscopy or diffuse optical imaging, where you have physical separation between your illuminator and the detection, where you can pull out structural information about the tissue. And on top of this, pretty much any other imaging technique that you can think of, you can use super continuum lasers for, and you can combine these techniques. You're not stuck with only doing one of them, since these sources are very, very flexible. So that brings me to at least my list of why use these super continuum lasers for endoscopy. They are super, super flexible. You get the full visible spectrum, you get the near-infrared spectrum, and we can tailor the color temperature and the spectrum that you send into your endoscope. The brightness is extremely high, and the heat footprint of the systems is low. And you have this advantage of going multimodal. You can combine various imaging techniques with each other to pull out much more information than you can with less advanced light sources. In terms of lifetime and total cost of ownership, I think this is also important. This is sometimes something we forget in our excitement of the great images we can pull out, but it's actually also really important if you have to get these systems out in a real clinical setting. It's important to remember that these things have a maintenance-free lifetime of tens of thousands of hours. And they are essentially service-free. That you don't have to alignment, you don't have to really do anything about them. You turn them on and they go. And that also brings with them a very low total cost of ownership. The upfront cost is probably a little bit higher for such a system compared to other light sources, but you can really set it and forget it for thousands and thousands of hours, which brings down the cost significantly. And then finally, this was also mentioned by Art, since this is a single mode source, it enables very small probes and very small endoscopes because the fiber that you can deliver it can be very, very thin. And we saw that you can get the same imaging quality out of these scanning single mode fibers that you can with the big bundles. And on top of that, of course, comes a lot of these imaging techniques that really only works in the single mode regime. So that's my very, very short, hopefully within the 6-minute pitch of white light lasers for endoscopy. And so what are we looking for here? We are very much a laser and light source manufacturer and a fiber manufacturer. And we are, of course, looking to partner up and team up with anybody who's the expert in bioimaging. And we are interested in teaming up with the endoscope manufacturers, the system integrators, basically those that are able to put all this together and make a product out of it.
Thank you very much for a great presentation. Look, I'm eternally thankful to NKT Photonics.
I
You
like
guys
that
have
cup. Thank you so
really
much.
beautiful cup. You also great water bottles, and thank you so much. That NKT is keeping coming to every meeting that we had in specialty fiber and in the supercontinuum laser segment. This market, the market of endoscopy, is a market where everyone say is the booming market. Actually, you should see the presentation that Slava gave and the previous meeting, which says this is a market like it's 10 times bigger than any other market in which we are going for specialty fiber. So I ask one of our key companies in the room on market analysis, GBF strategy, to tell us what he thinks. Daniel, thank you very much for joining this beautiful afternoon, at least here in the Netherlands. It's really, really nice now. I'm looking forward for this to finish and go outside. Daniel, what do you think of the endoscopy market?
It's certainly a very interesting market. Thank you for inviting me this afternoon. It's certainly my pleasure. Just as a point of note, I'm just outside Amsterdam as well. So this is almost entirely Hanseatic meeting today. Yeah, it's very interesting to listening to Kim talking about the various different products. This is a very interesting area for new technologies and new lasers, where we're breaking down boundaries in terms of what we can see inside the human body and what these diagnostic tests mean. Now, from my point of view, that's tremendously interesting because we're able to find new applications in all of these areas, from OCT to lifetime imaging, various different fluorescent confocal techniques. And it's very, very exciting to see, especially the super K sources, which are making differences. One question I had for Kim, which was specific to his talk, was to do with the confocal imaging, the fluoroscopy and otherwise. What do your new sources bring to confocal imaging, which was not previously available?
Compared to just normal standard lasers, or what are you thinking?
What's top of your list in terms of what you're changing?
Yeah, so compared to single line lasers in confocal imaging, I think some of the biggest things that we're bringing here. Well, we're actually bringing two major things. One thing is, since you have a big continuous spectrum here, you can tune these laser sources to any wavelength you want. That means that you can pick out fluorescent signals that can be very hard to pick out with standard lasers, simply because you don't have the wavelength that you need to hit just the peak of the absorption. So you can remove crosstalk. You can use other kind of labels that are simply not possible with standard single line lasers, where you are stuck with a number of colors, because here you can tune to any color you want, and you can tune and have various labels in your system and simply just pick them out one by one. So tremendously flexible system that gives you details that you cannot simply get with standard line lasers. The other thing is that this is a pulsed laser. So you can pull out lifetime information at the same time. They are very fast. They are typically in the order of 80 megahertz, but you can pick them down to kilohertz if that's what you want. But it's essentially a ultra wide tunable, ultra fast laser. So you get everything in one aperture. So I think that's the major thing that we bring.
Laser. Yeah. The possibility to do all these different imaging modes is the adaptability.
Yeah. And you can basically switch. You can basically switch between them. And I think what we see right now is that all these imaging techniques that have existed in the labs and existed in the microscopes, they are now moving into the endoscopes and being miniaturized. And these types of lasers are certainly some of those that enable that.
I have a comment from Slava.
To Kim, look, when you really put your laser fiber into the endoscope, how many channels there are? Is it just one fiber to excite fluorescence, what else? And then imaging endoscope bundle, which simply sits together? How it's designed?
Yeah, so, well, this depends on who we are working with, because we are not making the endoscope end of things. We are only providing the light source typically, and sometimes some excitation and collimation fibers. So it really depends, but we do have people where they have used our double clad fibers, where you have an excitation channel in the middle, and then you have a high numerical aperture on the outside to pick up the scattered light or the fluorescence. Yeah.
Okay. And how big is, let's say, you mentioned very good turnover, you know, for 400 guys, 75 million euro. How big is endoscopic application, if it's not a secret, of course, you know, for your sale of laser channel, I should say, to endoscope? So 10%, 1%, just order value.
I think it's probably in the single-digit % at the moment, at least.
Yeah.
Because this is still, I would say, this is still an emerging application where endoscope. I mean, if you're just making a very, very simple endoscope where you're looking for illumination using a white light laser is probably overkill. But if you're going into more advanced imaging techniques, and definitely when you're going multimodal, this becomes increasingly relevant. And I think, so we are riding that wave of endoscope evolution, where things are becoming much more intelligent than they were just a few years ago.
Okay, very clear. Thank you.
Thank you. I'm going to stay in Copenhagen because I love Denmark. Great breakfast I always have there. I'm going to Lars, with Lars from TU Denmark. You joined this meeting surrounded by industrial players in the endoscopy segment. What kind of things can you do for them? What can they do for you?
Well, the thing is, I've worked with endoscopy for quite some years. It went on hold a couple of years ago, and then I'm back in business working with the newly formed Department of Health Technology at the Technical University of Denmark. So I have been working a lot with bladder cancer, detection of tumors using autofluorescence and photodynamic diagnostics. And I'm happy to say that luminous devices, thank you very much for making very nice LEDs, and HOYA, thank you very much for making very nice filters. So I'm here because the group that I'm in now works in a lot of Europe, two very big Horizon 2020 programs, all related to endoscopy and detection of colorectal cancer and bladder cancer. So we are using whatever OCT, Raman, 2-photon excitation with ultra-fast lasers. So I'm really here to meet a lot of the people that I met many years ago and to see what's going on since I've been turning my back to this wonderful business.
You know what these people in this wonderful business love? They love challenges. You know,
Yes.
like chairing 24 hours meetings and crazy stuff like that.
Yes.
Tell us your Santa Claus Christmas list. This thing that you're looking for desperately and nobody can give it.
Well, probably we could find something, but right now we are mostly actually addressing something which is not addressed in this meeting. The back end, the analysis of the data. I think one of the big challenges right now is with all these wonderful light sources and optics and what have you, you can generate a humongous amount of data. And we also have to remember it is actually medical doctors who have to make the decision on treating the patient. So there's a lot of work to be done, and this is partly some of the stuff that I'm involved in now with artificial intelligence to make various algorithms that will help doctors to make more secure decisions on what they're actually being presented with. So I think that's perhaps one of the challenges, at least that I see today, that we have all the equipment, all the hardware that we have ever dreamt about, and I think the challenge is in data handling.
You tricked me there, Lars, because I was expecting a completely different answer. What I can tell you here is that Europe right now has the biggest revolution I have seen in the last 20 years in the field of we have now in Europe the best micro-optics in the world. Companies like FISPA, companies like you're going to hear later from Multiphoton, from Nanoscribe, from SUS Micro-Optics, and they really can address any challenge. So you can challenge them into any kind of freeform, multi-level. I think, for example, we have SUS Micro-Optics in the room, right? Where is my friend Wilfred? Wilfred, you're there in Neuchâtel.
Yes, hello.
How do you see from SUS Micro-Optics, a company that has grown exponentially in the last years in the automotive lighting segment? How is the medical market for SUS?
This is actually a very interesting question. Actually, before we did automotive lighting, we did endoscopes. So that was actually the enabler for the automotive market. So we do replicate lenses for endoscopes already since many years, very successfully for different applications. And it is a relatively small market, but it's a very interesting, very important market for us. And but what I liked when I saw the talk from NKT and from the fibers, what I like to know actually, how can we add micro-optics and illumination? Because imaging, a good image is also as good as its illumination. So I would love to know what the illumination people need for in terms of micro-optics or beam shaping. So with on the imaging side, we are already present quite strongly. So, but I want to do more.
Well, let's talk about that. This is the hottest topic we can talk about, adding micro-optics to the tip of a specialty fiber. Slava, how can we do this?
Yeah, I should say for last months, I should say, or two, we are under kind of bombing of interest how to make a tiny infrared endoscopes where tiny infrared micro-optics will be used. So it must be micro lenses, you know, which are size of, let's say, 1 to 2 millimeters, not always classic like hemispheric. It should be sometimes Fresnel lenses. So, and we are highly interested because it must be cheap solution, high volume.
No problem.
No problem?
We should talk, yes.
Oh yeah, not a problem at all. Lars, you have a question.
Could I just comment?
Yes.
One of the projects that we are running, we actually have University of St. Andrews throwing in their expertise on making airy discs or airy illumination. and other bezel function illumination. And I
Oh,
think
yes.
that's one of the great things today, that again, we have laser sources that are dirt cheap, that you can couple into a fiber, and you can place whatever phase optics or diffractive optics at the end of this fiber. And just a little reminder, I worked with diffractive optics for nearly 30 years. So I'm a particular happy person, because all the stuff that I did many years ago
Very good.
can
So
now
we should
be
be
made.
connected as well. Yeah. Okay.
So, yes.
Lars,
Yes.
that's why I was expecting the challenge on the micro-optics when I gave you the word. That's why you tricked me there with the data.
So-
I'm going to go because St. Andrews is beautiful, but not as beautiful as Limoges. So St. Andrews has golf, and Limoges has a tower that manufactures photonic crystal fiber. GLOphotonics is one of my favorite companies in Epic. Thank you very much for being with us this afternoon. Tell us about photonic crystal fiber. The floor is yours.
Thank you, Jose. Thank you, everybody, to be there into this discussion. It was very interesting to have some comments on endoscopy, because, you know, GLOphotonics, we are a small company making a lot of feedback input from different type of technology, and endoscopy is a very interesting technology for us. So just to give you some information on GLOphotonics, what we do.
Can we go to presentation mode?
I am in presentation mode.
Then you may be sharing the wrong screen.
Yes,
you are sharing the wrong screen. You can do it at the top of the window. Yes, now we're in business. The floor is yours.
Is it good? Okay. So the company has been funded in 2009 in Bath in the UK. We have a very strange birth, let's say, because we start in the UK and then we move in 2011 in Limoges in France. We start as a spin-off of the University of Limoges, and we shared at this moment in 2011 the drawing tower of the Limoges University, and then we involved into let's say single company, and we built our own we are able to make fiber, local fiber, of course. Yeah.
No, go ahead. We are fine.
Yeah, okay.
Go ahead.
We make local fiber since 2018. Sorry. Yes, 2018. Yes. And so we make local fiber, and we make only local fiber. We are not dedicated to make solid fiber. We are not playing on this game with a different partner. And since 2020, some people on the laser and on the machine side join us in the board of GLOphotonics as investor, like Trumpf and DMG Mori. They joined Amplitude System, which were one of the first investor in GLOphotonics. So now we are a small company, of course, 12 people, totally dedicated to make local fiber, but we have a lot of people following us and joining us to make something great with local fiber. So, sorry. So we have a drawing tower. We have 300, and we are able to make a local fiber and to test it and to functionalize the local fiber. So what is a local fiber? For some people who don't know what is this technology. In fact, local fiber is the only solution one of the only solutions, of course, able to guide ultrafast laser through a fiber. The local fiber is a fiber with a very specific structures around and inside the core. And due to the structures, the specific geometry, you are able to guide light for ultrafast laser, like femtosecond laser, picosecond laser, and nanosecond laser. There is different geometry, like the Kagome, the first one at your left, the one ring geometry, or we are able to make very specific geometry to address some very specific demand. And I will discuss a very specific demand we had about the past for endoscopy in order to address a very specific need in terms of NA, because the NA of this fiber could be very, very
We may be experiencing some IT problems all the way from beautiful Limoges. I know the technology very well, so I could actually even explain it myself.
Yes, you can hear me?
But it can't. Now, yes, I can.
Okay. I'm sorry, probably my connection is not very good. Jose?
Yes, yes, go ahead.
Okay, go ahead. Okay. And so the fiber could be drawn for different applications and for different wavelengths from UV up to infrared, even mid-infrared. So Slava from Photonics mentioned that there is a, let's say, cutoff due to silica. In fact, with the holocaust fiber, you can overcome this problem because holocaust fiber is made in silica, but as the laser will not interact with the silica, it will only be guided through the core of the fiber, you are able to go up to 3 micron, even 3.2 micron wavelength. So we are able to start at the UV 266 nanometer, and we're able to go through.
They go from the UV to the infrared.
We have make some, yeah, that's right. So there is a problem. Okay, I'm sorry with that. Probably my microphone is not very good. And so we are make some two different family. One family is a beam delivery family to help people to use the holocaust fiber. We have built a very specific family for low power energy, low power application. So it's just a cable you plug, you deplug with very standard connector, like FC connector, ACM connector, or any very standard connector dedicated to very standard application in order to ease the use of holocaust into the holocaust fiber. You need to evacuate the core of the fiber of air, of any gas, because even air could be a nonlinear medium, and you could damage the fiber at the end. So we have developed a very particular family of components where you can manage to evacuate the core of the fiber from gas and from air, and you are able to go up to 50 watt, 50 microjoule, even 100 watt, 100 microjoule with a femtosecond laser at 300 femtosecond. And if you can evacuate the core of the fiber, of course, you can put some gas inside the core of the fiber. And if you do so, you can exhaust some very interesting nonlinear phenomena like pulse compression inside the core of the fiber. You can start with a 300 femtosecond pulse, and you can compress the pulse down to 30 femtosecond, which could be very interesting. And it is a model very versatile. It means that we can do that for any wavelengths and for different type of. We can do also different things. It's to shift the frequency of the laser, the wavelengths. In fact, if you put gas inside the core fiber, you manage the pressure, you manage the type of gas. You can switch the wavelengths of one laser to another wavelength. For example, if you start at 1064 nanometer, we are able to go down to the UV by Raman convention. Okay, we will lose a lot of energy and power. The efficiency could be degraded, but we are able to go even in the UV with one wavelength, or we can create a count of wavelengths down to UV and up in the infrared. And to give you a very specific insight of the fiber, I would like to present you two standard fiber on the left, which is a classic fiber for us. On the two graph, you will see what we are able to offer in terms of standard fiber with very low losses on a broad range of wavelengths. So each wavelength, of course, is dedicated to one spectral region, but we can also make something very interesting to have a very broad spectrum of fiber from 400 nanometer up to 1550 nanometer. So you can cover a broad spectrum, and you can play with the laser, with a different laser, and you can inject different wavelengths in the same fiber. So definitely we can address different wavelengths, we can address different power and energy. And what we have developed recently with some partner in endoscopy is this very particular fiber. We know that one of the drawbacks of the fiber, or local fiber, I mean, is that the NA is very small. It's very, very small. It's something like 0.02, 0.01. So it is a problem for people in endoscopy. I mean, for people who want to make some multi-photon application, okay, no problem to inject with an ultrafast laser through a local fiber, but how to collect lights? That's a big problem. So what we have developed, and some partners have developed as well, it's a double clad structure. So the circle in red, in a light red, it's in fact the double cladding, which is 20 micron thick silica, let's say, yes, cladding. And so with this, you can collect light easily because the clad give you a NA of 0.16, 0.15. And right now we are trying to enhance the NA to have a larger NA by rendering something smaller in terms of thickness. So by this application, by this helical fiber, and if we combine the helical fiber with the silicon fiber technology, we are able to have something where you can inject via the helical fiber ultra-fast laser, like a femtosecond laser, and you can collect, you can harvest light through the silicon fiber due to a very, with a bigger NA due to the silica cladding. And of course, this fiber or this different helical fiber could be functionalized. The tip of the fiber could be functionalized with very dedicated system in order to put only an end cap to protect the fiber, of course, or we can put some micro optics like micro lens in order to collect a focus on the target we would like to enlight. So yes, we can do a lot of things. We can cover a lot of wavelengths. We can collect via silicon. But of course, what we need at GLOphotonics is to have much more information in terms of what the market need in terms of fiber, in terms of wavelengths, or in terms of NA. And in fact, the information for us, for this market, is very important to be able to target what we want to do in the future and what we will do in terms of very specific fibers. So if someone in the audience could give us some information on wavelengths of type of fiber and so on, that will be very interesting for us, and we will be able to focus the effort on this very specific topic. So thank you, and I'm sorry if there is some problem with the connection and on the presentation.
All good. Thank you so much, John. Thank you for the nice talk. And these are very interesting fibers, not only for endoscopy research as well, and metrology. Let me see if we have first a question in the room. Yeah, please, Slava.
Jean, it's really great what you are doing, and we are familiar that, of course, it can be recorded like, let's say, at 4.5 microns, let's say, anti-resonant fiber can be with losses, let's say, like 1 dB per kilometer. What else, you know? So this is really great future. Question: do you use only silica for your how to say, anti-resonant or crystals, yes, or it's also soft glass or infrared glass to go really up to 12 microns?
That's a great question. Now, for the moment, Slava, we are just focused on silica fibers, so silica ring, etc. But you're right. If we want to move in the infrared, in the 12 micron and so on, we have to move to another material to make the fiber. That is another step for GLOphotonics. For the moment, we are only dedicated to silica.
Yeah, but we are interested in some parts of system we manufacture. It will be excellent, really, to have this kind of combi effect when you have a good delivery of laser beam in the center and you collect light around. So just one fiber instead of bundle, instead of 2 fibers. Yeah. So we'll be in contact right after.
Yeah, great. Sure.
And I hope to see Limoges once, you know, after this stupid restrictions, we'll be waiting.
With pleasure, come to Limoges. It's a great place, underrated place.
You're welcome to Berlin. You know.
This is very nice. Thank you so much. Let me please introduce from Ocean Insight, Andrea. How are you? And please tell me how you find the meeting so far. And can you maybe answer
very interesting? Yeah, just so I'm from Ocean Insight, which is previously known as Ocean Optics. So we're mainly a kind of a research company, but we also specialize in mainly spectroscopy equipment and accessories. So we do have some fibers as well. I'm an insights manager, so I'm not as technically in tune with all of our products. So it's quite interesting for us in terms of we have some applications in endoscopy. We usually partner with endoscopy companies as such. So the reason we've decided to join the meeting is to have a look at what the kind of technical issues are here and some of the more interesting things we we found that looking at the kind of value propositions and what issues we could help solve in endoscopy. So I was a part of a team where we looked at how do you make sure that you can reuse a endoscope safely. So I have looking at the kind of cleaning processes and kind of more of a look at and kind of FDA approvals. So it's quite interesting in terms of more of the issues of the technical bit of the endoscope. But yeah, so I'm finding it very interesting in terms of capabilities of Ocean. We're able to make lots of kind of small handheld spectrometers for different applications, and we have a modular approach, so we can kind of adjust them per application. So we've got a lot of business in research, and then a lot of business and kind of more bigger companies for quality and things like that. Yeah, it's been very interesting.
Excellent. Can you maybe answer his question about the wavelength or the safe wavelength or the best wavelength that are the most demanded wavelength for this application?
I don't really know, sorry. Yeah, we were looking, so part of our team, we're looking at more of the market side. So I'm looking at what problem in the endoscopy market, what problems they're trying to solve. So if they're looking at a clearer picture, or if they're looking at maybe a tighter, kind of a more bendy fiber, anything like that. So I don't have the technicalities, but I'm looking.
It's good to know. So let me, at EPIC we do these excellent meetings, but also we are involved in European pilot lines. One of them is MedFab for photonics-based medical devices. And we have in the room Ralph.
Yes, hi. Hello.
Hi, Ralph. Can you introduce yourself, VTT, and what you do?
Yes, sure. So my name is Ralph Liedert. I'm representing, I think, both VTT today and the new MedFab pilot line, which is a brand new pilot line for photonic medical devices that just started beginning of the year. So it's all in establishment. It's a 4-year project. And what we can do for you, and hopefully for many in the room here, that we can help to pilot your devices. So we have a total of 18 high quality companies and research institutes in that pilot line project. And what we really try to do is to accelerate the commercialization of photonic diagnostic devices and instruments for treatment, for example. So reduction of R&D costs by having one single entry point to come with your problem. So you come to us, to our front office operations that we are now starting to ramp up. You ask the right questions, discuss and describe your technology problem, and you have 18 partners to think about your problem. So how can it be easier than that? So the idea is really to establish a well lubricated network of research institutes and companies that can really serve for the integration and system integration, upscaling, pilot manufacturing, from early research and development phase all the way to ISO 13485 type of manufacturing questions. We will be at Medica Component, hopefully, if it happens. I will give a little introduction talk there at the EPIC booth. And we also are open for early discussions, even though our front office operation and single entry point has not been established yet fully. We can be reached at info@medfab.eu. And we'd love to talk already in early stages with you guys, what your problems are and how you think a European pilot line could help to accelerate your business and your development.
Thank you so much for this introduction, Ralph, and for joining the meeting. You can also write to Jose to have the introduction to Ralph, or contact me or my colleague, Francesca Moglia, Dr. Francesca Moglia, responsible for this pilot line. So if there is no other questions.
There is a question from the YouTube universe. We are scouting people to ask questions, and the question is for one participant in the meeting, a company that I love, a company in Karlsruhe that I love, a company that makes accurate 3D print that I love, and the name is Nanoscribe. The question is for Nanoscribe. The person who is not revealing his identity, but I think I know who he is. He says, I talked to Nanoscribe at Photonics West, and the reason that they have had developed technology to write lenses on the tip of a fiber is to have disposable endoscopes. Is that the future of endoscopy?
Hello, Jose. Thanks for asking that question, or thanks for the person at YouTube asking that question.
I think we know who he is.
I'm unable to answer it. I'm not the one who's doing the endoscopes, so I have to put the question best. Yes, there is a lot of requests for disposable endoscopes, but the question is how easy and quick you can print the optics or this disposable endoscopes. And I don't have all the information on this, so I'm not able to answer that question, unfortunately. We print on endoscopes, we print on fibers, single lenses, double lenses. So these are things we are capable of doing, and where we are looking for partner to continue to develop this technology.
Great, because one thing that I'm always worried is these guys from Berlin, Photonics, GLOphotonics from Limoges, they make really fantastic specialty fiber. We also have OFS in the room. They make great, fantastic specialty fiber. Is it possible to really print micro optics at the edge of a photonic crystal fiber, of a mid-infrared fiber? Is it possible? That's something that you have done in the past?
Photonic crystal fiber, I'm not aware of. Different fibers, yes, we have done this, yeah.
I'm gonna ask to my very good friend from OFS who joined the meeting today. Thank you very much today, Steve, for being with us. What's the time for you right now?
It is something like 10 o'clock, 10 a.m.
Good morning. I hope you're enjoying your nice cup of coffee. Look at the mug that I got from one of the members. Doesn't it look fantastic? Steve, why did you join this meeting today? What kind of partnerships are we looking for?
Good question. The types of partnerships that we are looking for is on the system side. Like many of the fiber companies on the call today, we make all kinds of different specialty fibers. So when we develop something new, many times that requires a change on the system. How likely is that to happen? How likely is a supplier that's a component deep within a system to affect the development of the system itself? So looking for partners on the system side to answer questions like that.
The future of endoscopy is here in the room. Actually, I've been scouting for many years, new things happening in this sector. We have actually two endoscope manufacturers in the room, but they didn't want to be in the room, which Olympus and Richard Wolf, but they are giving me feedback at the same time. But they are not in the room, but they are here. But there is a European funded project that is catching the attention of many big industrial companies who actually asked me to bring them to the room. So I'm going to go to a beautiful city in the north of Spain. It's called Zaragoza, with double Z, Zaragoza, and they make fantastic technology at the university there. I know many people at that university, and they are coordinating the EndoMapper project. Jose Montiel, thank you very much for joining this industrial meeting today. I don't know if we can hear Jose right now.
Yeah, hello.
Yes, I hear you loud and clear, and I see the books behind you. Thank you very much for joining from Aragon in Spain. What is EndoMapper?
Well, this project is in sharp contrast with what we are listening in this room. We are going to be in endoscopy, but we are just going to process the images coming from a monocular standard endoscope. And the idea is that while we get these images live, at the same time, we make a 3D model of the area in which we are moving the endoscope. The idea is to be able to make a geometrical model live in real time of the surroundings, and more importantly, to very accurate locate the tip on the endoscope with respect to this area. It's like having a map specific for the patient and being able to locate the endoscope within this map. This is basically the idea of the project.
This looks fascinating. Tell me that you have a picture or something to show me to make it a bit more visual.
I will try how I should share. I have a slide, but
at the bottom of the screen, there is a button that says share screen with an arrow up. It's green.
Okay, so this is my screen.
For those of you who are wondering if this was prepared, of course not.
Okay.
There was nothing prepared here.
This is. So the idea is, well, we come from robotics. So in this video, you can see how the system works in a car. So basically, what you see here is that you have the camera in front of the car, And from the images, what you see in the bottom part is a model, a map of the streets where the car is moving. And this small triangle here is where is the car located with the map that we are building at the same time as we are moving. So this is the idea that when we move down the road, we are able to make from the images of the camera a map of the surroundings and to locate ourselves where we are in that map. Then what is the project? Well, the idea is if we are able to do this within a car, can we do this from endoscopies? So then we will be able to move to make the map. Is this fine? Can you hear me?
I can hear you. I can see it, and it's exactly what I was expecting to see. It is. This is the future. Well, it has been seen as a FET open, which is blue sky research, and already is attracting the eye of many companies in the industry. I would like to know, this is what you are developing, but how do you see this reaching the industry in the next 5 to 10 years? Which kind of companies would you like to engage with? I know University of Zaragoza is going very much towards helping industry. So which kind of companies from here can help you to make your dreams come true?
For me, the idea that typical partner will be an endoscopy company, because basically we don't need anything additional. We need the images from the camera, and then we are going to use kind of regular computers. So the good thing is that we can transform a normal endoscope, this is our dream, in an instrument that is able to locate very accurately. For example, in terms of going back to the same place 1 month afterwards, we will be able to provide instructions to the doctor saying, go ahead, go right. This is the place where you made the biopsy, something like a month ago. Or to locate very accurately where is the tip of the endoscope with respect to the surface of the body. This is basically, I think, what we can offer.
Thank you very much, Jose. There are going to be a couple of people who already asked me to be introduced to you. So follow up and welcome to your first ever EPIC event, actually for the whole University of Zaragoza, first ever EPIC event. Welcome to EPIC. Happy to have Mañolandia in this network. And I would like to go back to Dr. Sana-Pyka.
Thank you so much, Jose. And as you know, every time I hear something about precision positioning, I remember our friend here, Thomas from PI. Thomas, how are you doing? And how is this working for endoscopy? Hello?
Yes, hello. So I'm fine. Hello to everyone. So can you please repeat the question?
So I wanted to know your activity in endoscopy, if you can introduce yourself and what you do.
Okay. So the company of PI, so Physikinstrumente, we are suppliers for piezo elements for fiber-based scanning endoscopes. And we also suppliers for precision drives for video endoscopes. So that's our business.
Thank you so much. Okay, then if there is no other questions in the room, I would like to go to the next speaker from IMASENIC. From IMASENIC, we have Renato.
Hello, good afternoon.
Hi, Renato. Thank you so much for joining. So we will start now speaking about the sensors and imaging. We're looking forward to your talk.
My pleasure to be here. So I'm going to share my screen. You can see it. So can you see it?
We see it crystal clear, Renato.
Excellent. So as you said, I'm going to talk about the image sensors. So I'm the CEO and co-founder of IMASENIC. We are based in Barcelona. So you see here some pictures, and we are located very close to this place. And the amount of people around the street a few days ago was about the same you see in this picture. So nobody, a bit now more people there. So we are two founders, myself and another person, and we have a long experience in semiconductor industry. We come from two backgrounds quite complementary. So we come from myself from the scientific and my partner from the consumer background. So we thought it was very good match to develop custom image sensors. And basically this stays in the focus of the company, and we want to be, so we are innovative and cost effective, and we are used to deal with a lot of different applications. So myself, I come from scientific background, so I'm used to all sorts of different things, and sometimes starting from just an idea, 2 lines of an idea, or sometimes very detailed specification, but even from a line, from 2 lines, we can develop a specification for a sensor, which will become a product. And that's what we do. So we develop products for companies. And here you see a bit the different things we do. So as I said, starting from the specification, and then our core activity, where is, let's say, where we bring innovation is in the CMOS design. And for these, we use also the state-of-the-art tools from very well-known companies. For what concerns the manufacturing, we use CMOS foundries around the world, as you probably know. So these are big animals, big companies, and so we are what, like other companies, we are what is called a fabless semiconductor company. So we don't have a fab, but this is not necessarily a drawback, because it means we are flexible. We can go to basically any fab. We're not linked to a specific company. And so we can use different technologies, and let's say the best technology, which adapt the best to the project. And we have access to CMOS image sensor technology down to the 40 nanometer node, which means we can do a lot of different things. I will tell you a few more things later, but also what is important, for example, for endoscopy, you can do small pixels and a lot of them, and put them in a very small chip, which goes on the tip of the endoscope. And then, so once we have the chip, then we can take care of the tests, so the silicon sampling, and we developed our own evaluation platform that we call Evalima, which is it's a mixture of hardware and software, so that basically it's easy and cost effective to develop also very new pixels, where you have to do a lot, develop new things. And so it's important to have a platform that allows to do innovation, but in a cost-effective way. And then when we do all the interface with the foundry, so our customers don't have to worry about talking to CMOS manufacturer, which can be quite, I mean, it's quite specialized and quite complex manufacturing. So we take care of this, and we take care also the volume production when we come to that. And we can also develop the package and the camera module, which goes beyond, which goes with a sensor. And wow, as you see, the title of the slide has got the cost effective. One important thing is to be, so the design of a chip is always a complex animal. So there are a lot of things which has to be right in order for the chip to work correctly. And so our goal is to get everything right first time. So there's no modification that needs to be done on the chip. So we go from, let's say, all this line, it really follows the template path. There's no going back from one case to another one to do a modification. And in terms of application, we actually started from the biomedical and scientific field. And I have to say medical, we started from X-ray, so it was big pixels and big sensors. But now we are also starting working on small pixels and also for endoscopy. And yeah, so we have done sensors in these areas, so the initial areas where we were active. But then we can see that CMOS image sensor is quite ubiquitous, and a lot of different applications which require different adaptation, different innovation, and so on. So we are now active also in other fields with space and aeronautics, Earth observation, industrial and also consumer for smart sensor and automotive. So I hope this, was a very brief presentation about what we do. Now going to the key slides that Jose always wants to see. That's the first one. What can we do? And well, it would be quite difficult actually to summarize in one slide. So I just put the big blob there. So we can do CMOS image sensor with innovation, adding new things. And here is a list of some of the things we do. There is much more. So in general, I would say if you have a need or even an idea on something new that can be done and where you would require a new image sensor you can't find in the market, come and talk to us. And most of the time I would say we can help you. We can give you at least what you want. And very often we give you more than what you thought you could have. So this is a list of things. So people who know a bit about imaging know probably about rolling shutter pixel, global shutter, which are more like giving a snapshot. So sensor which can give a snapshot. I say they're pixel, but to be clear, we also do the sensor, the full sensor from the pixel to the output data. So you don't have to worry about interface. We take care of this. And we just give you a nice image. We can do single photon detecting pixels. For example, with single photon avalanche detectors, which is a kind of, per se is not a new technology, but it's a kind of new technology in CMOS. And so we can integrate a lot of these pixels, which have not only a great sensitivity, but also the capability of getting timing. And this can be useful, for example, if one wants to measure fluorescence lifetime of biological markers. So that can be very useful. And we can do pixels with great quantum efficiency, low noise, high dynamic range, low power, which is also an important aspect for endoscopes, especially if you look, for example, at kind of endoscope like a camera in a pill, where you don't have the option to connect with an external power supply. And as I said, we do the whole chip. So it's like in a single piece of silicon, you have not only the imaging array, but also all the control electronics. Stack sensor is maybe that's a bit more technical, but basically it allows to put the sensor on top of another chip, which can do more and do processing and other things. And also one thing where we are expert and fairly unique in the field is that, of course, we can detect visible light, but we also know how to get good efficiency in infrared and ultraviolet. So that was about what we can do. Last slide, which is also a pet favorite of Jose, is what we look for here is, of course, we know the endoscope has got different elements, and we look for people who are expert in optics, also in illumination, in getting the right casing. We heard about fiber optics, and also like someone else also was saying, we look for system integrators. So we do the chip, we can do the innovative image sensor, but then we need also all the other part in the supply chain to make a product. So this is my last slide. Hope I was in the 6 minutes.
Thank you very much for a great presentation. You are always in the 6 minutes. And I think I have my very good friend Holger really showing us something. I want to know what he's showing us. Holger, what do you have in your hands? And be careful, don't drop it. It looks expensive. And he's going to say, it looks expensive, but it's cost efficient. Holger, I think I have you muted and I want to hear you. Yes.
Yes. Are you hearing me?
Loud and clear. Yes.
Okay. So first of all, welcome, or not opposite. Thank you much for joining. And I just wanted to show you what we can do for you. We are the experts for the casing. It can be the different kind of casing, which you can see here. We are working together with a Korean manufacturer called, this is called MetaLife. And if you're interested, we can do all kind of various ceramics, which you can see here. Is mostly it's custom specified, but it works in small quantities and also works in high volume, of course. Another which we are doing is for high power laser casing like this, where you put the optics, the SACs or the FACs in here, and then you can do some laser modules up to 150, 200 watts or whatever you would like to do. This is just a short introduction from our side.
Thank you very much for that. And I honestly, from IMASENIC side, when it comes to partnership, one of the key things here, of course, is to partner the sensors into a package. Has that been a challenge for IMASENIC? Are you looking for potential partnerships on that?
So yes, I think on a number of projects. So yeah, we're looking for partners now for packaging. Yeah, because we have a lot of fairly specialized sensors or with different requirements. So I think what the Holger was saying is very interesting, and definitely it's a good connection.
So I will have a Q&A now, but I'm so excited about the next presentation because it really can help you on that particular side, on the packaging. I'm going to cross now to Anna Nikiel. We've known Anna already for many years. She's been working in the medical sector, and even lobbying in Brussels, in the corridors of Brussels for this technology. And now she's leading business development at Technobis in Almar, in the Netherlands. And we know Technobis very strongly from the datacom and aerospace sectors. But today she's talking about endoscopy, and I'm very curious about a company that does the high-end packaging and assembly of photonic integrated circuits in fiber sensors. What a company like that can do in endoscopy. Anna Nikiel, thank you very much for being with us this beautiful afternoon here for us in the Netherlands. The floor and the attention of everyone is yours.
Thank you, Jose. It's a pleasure to be taking part in my first EPIC online meeting. And let me share the screen. Can you see my screen now? Yes.
We see crystal clear the way that we see you too.
Okay. First, let me highlight some recent changes at the Technobis headquarters in Alkmaar. So indeed, our heritage is in the fiber brag gratings for the aerospace. But we quickly realized that putting 5,000 sensors into single fiber had other applications, like, for example, in the medical fields. So you may know our work from the temperature on strain interrogators. And we recently opened also 2 big packaging lines for offering contract manufacturing to our partners. And this is, of course, extension of our partnership with a PIXA pilot line, which we have always regarded as a very important European initiative. However, today I would like to share with you some medical ideas which we're working on. Wow. Yeah. So as we heard before on the meeting, the development of the optical fiber bundles is in the last century accelerate the breakthrough, yeah, producing the first flexible endoscope. But I would argue that today endoscope requires more than sophisticated cameras. Surgeons tell us that having real-time data at their fingertip would improve both the guidance and accuracy of their work. And which is why the other breaking for endoscopy and catheters in general is the using of the fiber grating. As we learned from the aerospace, one silica fibers can carry real data with a high accuracy measurements of the strain, temperature, and pressure. And when applied to endoscopy, silica fibers offer the advantage of the small size and zero toxicity. They are also chemically inert, and they are designed for the in vivo measurement, but can also be left in the position for repeat or continuous measurements. In Technobis, we are known from being early adopter of the integrated photonics as an optical processor. And this approach allows us to reduce device dimension, power consumption, and at the same time increase measurement resolution and accuracy. So we are working on the various types of the sensor for the healthcare market, but let me highlight some areas that might interest these endoscopy meetings. Yes, for example, fiber optic shape sensing has, I think, a very great potential for the several medical application to sense curvated and the shape in both 2D and the 3D. And tracking system based on the FPGAs are the emerging technology for the navigation of the minimal invasive instrument. It means that we can reduce patient X-ray exposure and amount of the contrast which we use. And here we have also another example of the same principle, which can be used to help people walk again. By wearing our fiber attached to the back of your neck, we can analyze the walking gain. This can be help to predict the movement needed to drive exoskeleton. Another one of the challenges in the endoscopy is that the surgeon is not in the direct contact with the tissue. So he or she doesn't know how tight to grip, and we know this can lead to damage of the healthy tissue. So there is a very easy solution, haptic feedback, which is already known in the game controllers and can be used to create the sensation of the touch. And this helps the surgeon know the level of the force being applied. An in vivo experiment with these tools made it possible to feel the heartbeat in the blood vessels through the handlebar controller. Another example of the force sensing is our minimal invasive biopsy needle. This enables more accurate tissue characterization and more precision navigation. I also know from talking to surgeons that there is a big need for a high accuracy absolute temperature sensing. And our integrator is designed to operate in RF and MRI environment where another sensor can't operate. And what I think that is very important, we can achieve a very high stability for a period over 4 hours. Let me share the funny story with our accidental discovery of respiratory function monitoring. So recently we tried to measure temperature, but we made kind of the mistake in the setting up our sensor, and we ended up measuring the breathing motion, so respiratory function, by attaching the sensor to the wrist. And I think that we obtain extremely high accuracy with a standard deviation of the 10 femtometer, which I think is pretty impressive. Yeah, so here in Technobis, we have a broad portfolio of our gators, which you might find interested. We are ready to go with the world's first wearable gator system, and it may be of the size of the USB drive, but it still offers hundreds of the sensor per fiber. And following the EPIC partnership guidance, we have built the partnership with EPIC members. This includes what we regard as the best world FPG suppliers like Teraxion, FPGS, and a few others. So this brings me to the EPIC question. And first, I would like to thank you for what EPIC members have already been doing during this great online meeting. For example, you already, Jose, mentioned this Stefano Rugocci in the June 2nd meeting. He flagged the need for the temperature monitoring in the operation he does for the prostate cancer. So we'd like to know and get more input from the physician on relevant real-time data like temperature and pressure. So what kind of the specs are really needed in practice? And of course, we are actively reaching out to the partner with other endoscopic device manufacturers. And we think we may have technology that could be combined and packaged to very quickly launch a product that surgeon needed now. And yeah, that's all. And thank you for attention. And of course, I'm always happy to follow up. Thank you.
Thank you so much for this very nice talk and for appreciating what EPIC is doing for the members. This is one of the most important part of our job. Let me first see, I think I saw some hands rising for questions before I continue. Yes, please unmute. Please unmute, Lars. Yeah.
No, I just gave a hand for applause.
That was just a hi.
Yeah.
Okay, no problem.
Hello.
This is nice. So I'm really looking forward after this nice talk to introduce one of the catheters manufacturers in endoscopy. I'm very happy that EndoPhotonics just joined us. Peter Schenk. Can you please unmute? How are you doing?
Hi.
Hi.
This is Peter from EndoPhotonics.
Thank you so much. Please tell us what you do.
EndoPhotonics is really a company about helping people to discover cancer early. And our first two products is actually a product for gastric cancer. And the whole technology is leveraged on a Raman spectroscopy and machine learning. So we are having a regular, our local regulatory clearing should be done by August, and hopefully by the end of the year we will get the CE mark. Yeah.
Is there something challenging you would like to ask the companies that are in the room for? What is your wish list?
I think my good friend should be on. I don't know whether. Okay, Slavia, you're around. Okay.
We can do the meeting without Slavia here.
Yeah. Basically, I think one of the challenges really is to work towards because currently what we have is we have a probe that uses the operation channel of the endoscope. So the probe should have to be at least 2 meters long. It's rather expensive. I think in the future with COVID happening and with all the other viruses happening around, I think society is going to move towards more and more a single-use probe. So our current technology is just not cost-effective enough to be able to work towards that. And that is something that I will always be looking out for.
Thank you so much. Would you like to comment on that? Yeah, of course. Please unmute.
Nice to see you, Peter. What's time right now in Singapore? I think you really should sleep this time.
Yeah, it's past 11 over here.
He looks really awake. Peter is always really awake. Whenever you see him around the world, he's always there to high five you. Peter, thank you so much for joining today. Anna, Nikiel, you're looking for more catheters manufacturers? We have FISVA in the room. Thank you very much for joining the meeting today. Henny, how are you doing?
I'm fine. How are you?
I think Anna is looking for catheters. So you can see me. Oh, we're super excited.
Yeah.
Anna is looking for catheters manufacturers. Can FISVA help her?
For catheters, not. We're just doing the optics inside, as I will show you in a few moments.
You can just start the talk.
Yeah, okay.
Yeah,
so let me...
We have a question in the room before the talk. Is hand up my very good friend from River D Diagnostic, Gerwin. What's in your mind?
Yes, thank you very much. A very interesting meeting thus far. I'm very pleased to see Peter Cheng here. I don't know if we have ever met before, but I have a very good relationship with Jiwei Wang, who I know was instrumental in starting EndoPhotonics. Yes, if you say that your current probe is not cost effective enough, we have been working for many years using just the high wave number region and the Raman, where you can simply use a single piece of fiber without any background problems. You just go back and forth through the same fiber. I don't think it gets any cheaper than that. Be a solution for you.
Yeah, so then maybe it's something that we can talk about.
Yeah.
Because we are looking at both high wave number and fingerprint at the same time.
Yes, so we have focused very much on finding applications where the high wave number region alone is sufficient. And we have seen very few cases where it isn't sufficient. So,
okay.
So I'd be happy to talk to you about this.
Maybe we can contact after the meeting. We can chit chat about it.
Sure.
Excellent, Jose. A lot of introductions.
Anna Nikiel, I love doing the introductions, no problem. Anna Nikiel, I'm really super excited about the haptic feedback. I touched the first, I was amazed. It's super nice to feel that this is based to the FVG technology that you are developing. Are you looking for certain partners on that to help you develop that business line, which is by the way, if any of you have the chance to touch, the thing is fascinating.
Yeah, it is. I agree. But actually, I agree with Slava, what he mentioned on the beginning, that is, and I think that you had the same impression. It's quite difficult to get in touch and to partnership with big companies of this world, the Philips of this world. So I think that the power of the EPIC is that we can combine the SMEs and companies like Technobis with companies which have another technology, combine this together and bring it to the market, because it's always easy to partner and do something with the cost-wise and FDA approval and so on. So in principle, yeah, we are looking for the partners who could make our offer maybe more rich, or maybe maybe they have some ideas what they would like to measure, like a physician, or maybe they would like to integrate our modules with haptic feedback, with a temperature measurement, with shape sensing. Yeah, maybe they would like to integrate this module to their device.
Bram from FBGS, thank you very much for joining all the way from beautiful Belgium. Bram, in the field of endoscopy, the FBG market is being taken over. You see a big pool?
Thank you, Jose, for asking that question. Yes, we see actually more and more interest, as Anna nicely introduced the possibilities of FBG sensing. So it's not only about temperature, it's also about shape, pressure, and all these types of new sensing means are for sure of interest in that market. It's a bit early days still, but we see there a huge potential. There are some prototype products available and being tested. So it's for sure for us a market where we want to dig deeper, let's say, and find the right partnerships. And Technobis is, of course, a perfect example of an interrogator which is built very cost effective, and we can put there the cost effective fiber, including Bragg ratings for sensing purposes next to that. So that's, of course, could be a very good match in this area, I would say. Yes.
What I want to add, and usually what customers asking us, so our hardware, which Technobis produces, a device which companies, hospital buy usually once, but the real cost is with a fibers, with a disposable. So the companies like Teraxion, FPGS, working very hard to make a production as cheap as possible to get with this disposable, below certain amount that could be used as a disposable. This is really, I think, that cost factor which have to go down, because interrogators, the price, and I think that Tim Katz, the founder of the company, said on the EPIC online meeting a few times that we reduce our costs, and this is our roadmap, that of course the interrogator will be cheap. But I think that what the end customers wanted, they really want to have a cheap fibers.
Thank you so much for this nice overview, Anna. And again, for any introduction, Jose will be able, just write him a short email. He will put you in contact.
Thank you, guys. I'm really looking forward.
This is very nice. Again, now you wanted an Caterham manufacturer. We're back to FISBA. We're looking forward to hear the talk from Henning.
Yeah, thanks, Anna. Can you see my screen?
Yes, perfect.
Yeah, nice. Okay, welcome to everybody, and this is a small step in the world of the mainstream endoscopy, and I hope I will show you this kinds of legacy stuff is neither boring nor old or they're not so interesting. And of course, I want to give you a short insight into my company. Yeah, FISBA is a family-owned company, maybe 60 years old, in St. Gallen in Switzerland, with some offices in the US and Germany and China. And we are doing, say, I would call it micro-optic rather than photonics. So we are really into tiny, sophisticated optical systems, and we do real business with that. So it's about 400 people and 60 million per year. And I will show you what we are doing. So the first main business line is medical optics. So this is really high quality imaging optics. Yes, in big quantities. So you see lenses with a diameter of less than 1 millimeter. So we normally don't do optics larger than 20 or 30 millimeters. So the small and expensive stuff is our business. Yeah. So endoscopy is the biggest market for this, but we also produce micro cameras, including the sensor and lighting for other markets. So in endoscopy, the main applications are rigid endoscopes, which have a set of lenses in a metal tube and have an image sensor outside the body. And the other type are the chip-on-tip systems with the image sensor on the tip of the endoscope. This became possible maybe for the last 20 years with the rise of small image sensors. And for this kind of systems, yes, we are talking about real resolutions. We are now talking about 8K resolutions for endoscopy, which is really some weird stuff. Yeah, we do build to print. This means customers come to our facility with some drawings and we just produce the lenses. And we do customized designs. This means we just receive a specification and design the system and produce all the optics for the customers. And yes, we have our own coding inside and everything. I will show you one example. This is an endoscopy system which came from a recent research project. So this is a 10-lens system where the yellow part is the image sensor with the wiring, and lighting is also inside this in terms of a fiber and some fiber outlets. And the 10 lens elements are organized in a few groups. And so as you would assume, the whole diameter is in the order of 4 millimeters. And the crazy thing here is that one lens is movable by some actors. So this is in the moment used for focusing, but we consider producing also zoom optics in this size. Okay, another thing is the production and development of light sources for endoscopy. So we are doing laser and LED modules. In the case of lasers, 3-color single mode systems, or even more than 3 colors, everything coupled to a fiber, as you see on the left. And this is applied for life sciences, biophotonics, fluorescence, and maybe ophthalmics. But we are also developing LED engines, as you can see on the right, tiny engine which is producing light for an endoscope. So this is another line. And what does not belong to endoscopy, but we are also doing optics for diode lasers in large quantities. And you can see here some cylindrical lenses, FACs, SACs for diode lasers, which is a growing business. Yeah, and that's already all I wanted to show you from my company FISPA, and I'm waiting for questions.
Thank you so much for the nice talk.
Hi, this is Peter. I have a question. The lenses that you are making, the elements, are they mainly plastics, or you also work with fused silica glass?
It's neither fused silica nor plastic. That's optical glass. And we do the say, standard grinding polishing stuff as well on automatic lines, but also with manual production. And we do lens molding, but everything made from glass.
Okay, thank you.
Get going.
Yeah, I guess Peter and I have the same sort of thing in mind. I mean, we design our own microscope objectives specifically tuned for Raman spectroscopy, and one of the input requirements is that we use only glasses that have a very low background. So are there any particular materials that you do not use, like calcium fluoride or?
Normally we don't use calcium fluoride because there's not much UV business. It's mainly for visible and near infrared.
Yeah. But I'm very impressed with this 10 element. I'm sure you're showing it for a purpose, but I'm very impressed with such a small and complicated thing. So that's and I would like to complicate it a little bit more by saying, okay, you cannot use those and those materials because they will ruin the Raman signal that we are interested in. So
you're welcome to send me an email.
Yeah, okay, I will be in touch later. Yeah.
There is another message, I think, from Thomas, from PI. Thomas.
Yes, thank you. So a great talk, Henning. You mentioned your 4 millimeter diameter endoscope, and you talked about an actor for the focusing of this optical lens group. So what is the technology used for these actors?
I'm not sure whether I can publicly describe it, but it's a bit tricky here. Okay.
Okay.
Tell us something. Just something.
It's okay.
Nobody's listening to this. Only some YouTubers and nothing.
Okay, maybe we can do it offline, Henning, or later. Yeah. Okay.
Just a question, because it was very impressive. You did all the the micro systems. Have you done anything that is been able to autoclave?
There's a big discussion in endoscopy. I think yes, and there are different autoclave systems from low temperature chemical stuff up to high temperature and whatever else. But I think we are mainly a supplier of optical parts and components and modules, and so we don't care too much about this stuff. This is a topic for all customers.
Okay, understand. Thank you.
Could I just comment here? It's a common misconception that you need to autoclave. I mean, there are most medical endoscopes are actually washed or given a procedure with a combination of UV light and water. It's a system developed by Johnson & Johnson. Like, forgot the name, but they don't think about autoclavable things when it's endoscopes, because whatever you try to do, you will burst it wide open.
Thank you.
Thank you so much. Then we can move to the next talk from Multiphoton Optics. Yannick, we're very happy to have you. And greetings to Ruth, if I'm sure she's watching.
I'm sure she is. Can you see my screen already? Hold on.
Now, yes. Yes, excellent. You can just start.
Oh, was that correct? Sorry. Give me a second.
It was good.
Oh, yeah. It was wrong for me. Sorry about that.
Okay, now it's working.
Is it working already?
Yes.
Okay, fantastic. Then thank you very much for having me here and for giving me the opportunity to present the integration of biocompatible micro-optics. I'm Yannick Dupuy, and I'm an application engineer for multiphoton optics with a working focus on this. On the right-hand side, you see our main product, a 3D lithography equipment, and that enables us to fabricate micro-optics. The goal of this presentation is to demonstrate how 3D lithography can replace and complement the current manufacturing processes. The Multiphoton Optics is a spin-off of the Fraunhofer Institute in Würzburg, and it's a growing company. We supply hardware, but also support our customers with prototyping and engineering projects and in small series to volume production. We have strong expertise in technology, materials, software, and integration, coupled with a full set of IP and registered brands that provide an exclusive access to know-how. We're currently 18 employees, and we are in negotiations with distributors from Japan that might be closed this summer. Looking at our main product, hold on. It's not on. Here we go. Which is the 3D lithography equipment, which uses maskless lithography by direct laser writing. With a good idea as a key to a product, we can fabricate structures using our 3D lithography technology in an additive or a subtractive manner. For this purpose, we can use various conventional or research photoresists or perform metal structuring or use photopatternable glass. The 3D lithography equipment is not only flexible on the material that is to be structured, but also on the structure size that is scalable from the nano scale to for metal lens applications all the way to the macro scale for larger optics. We also have freedom of shape. Looking at spherical shapes, going to aspherical shapes, all the way to freeform surfaces. And also the scalability is given. Here you can see a 4-inch wafer with more than 26,000 lenses on there, or a 6-inch wafer with more than 86,000 lenses on there. Keeping this abundant processing freedom in mind, we can have a look at some examples regarding endoscopic applications. Here you can see some different lens stack examples. Some relevant key facts for using MPO's 3D lithography equipment is that you can fabricate those structures on any substrate. So you can write directly on a fiber or on an imaging chip, adjust the roughness all the way down to approximately 5 nanometer, and basically any freeform surface is possible. The fabrication is typically performed within one single process step with no post-processing of the surfaces that you see on the left-hand side. And we have, typical for additive manufacturing, fast access to prototypes. Also upscale to small series and volume production is possible. Let us have a look at a comparison of the fabrication of an endoscopic objective lens using the current manufacturing process that uses ground and polished optics in comparison to the novel approach using MPO's high precision 3D lithography equipment. While the conventional process of the assembly of the optical components glues parts in typically manual labor with additional tools for alignment. MPO's approach is assembly free since the optical components are fabricated within one single process step. In the current manufacturing process, the profile shape accuracy can be as low as 300 nanometer as far as I know. While in our typical fabrication process, the profile shape accuracy is below 300 nanometer. Due to the mentioned simplification of the process, further tolerances are inherent in the fabrication procedure for our lithography process. And the diameter ranges from approximately tens of micrometer all the way in the several millimeter range, as you could also see with the optics I showed you earlier. With this information regarding the opportunities to manufacture optics with multi-photon optics 3D lithography, let us have a look at the biocompatibility of a typical almost-air photoresist that is used to fabricate optics. On the left-hand side, you see different structures that were fabricated using high-precision 3D lithography. The cell adhesion and proliferation tests on these structures depict that the cells grow on those structures, and the cell growth can be influenced by the structure's topology as well. Besides non-degradable material, there's also biocompatible degradable material that can be useful for some applications. And the biocompatibility can be seen here, for example, by the cell division of a microvascular endothelial cell that was observed on one of those structures itself. To sum up the presentation, I'd like to display some of the abundant examples of what we can fabricate with our technology, going from bone cartilage transplants to optical interconnects, to the production on wafer scale, to edge emitting laser coupling, Also here, micro-optics on VCSELs or on LEDs, some lens stacks, retroreflector, a meta lens, TPA on SLA, and the parallelization of the fabrication. Well, thank you very much for listening to this. And thank you very much to the Epping team for organizing this event and all the other events in the last couple of weeks.
And thank you very much for your fantastic micro-optics printing technology and to photon polymerization, great equipment, and the great job that you do cooperating with many of our members. Today, we already have the hand up from my friend Slava. Slava, what's in your mind?
Yannick, a very interesting question. Your material used for this kind of microstructures, it's always based on silicon only, or it can be some other materials which are much harder, like sapphire, diamond, even metal? Because we are looking for the structures like you show, but we would like to make embossing of the structures in our relatively soft material. Is it possible?
So using so one material class that we like to use is the called Omosairs. They have great optical qualities, but they can also be used for replication. So you can use those to replicate your structures over and over again. So we have done some testing on that as well that we can maybe show you.
It's not fragile. It's not brittle. It's
no. Yeah.
Okay, because we are interested in both options, because right now we already try to use, how to say, optical contact of our infrared fiber with diamond lenses. But diamond lenses have this kind of microstructure outside to suppress Fresnel, because I hope that in general this problem with infrared material is the same for many people, because high refractive index and we have high Fresnel reflection. So we try to fight with this problem by special microstructures. And I think you are familiar with that, because
yes, absolutely.
Yeah. Okay, it will be great to be in contact after this.
That's the epic attitude. So Multiphoton has for many years helping companies print micro-optics anywhere, which has been seen as a unique selling point for packaging of assembly of any photonic structure, including of course endoscopes. I'm going to introduce you to a friend of mine. Andrew Robertson is here from Photonics. Andrew, how are you doing?
Hi there, Jose. I'm doing very well, thank you.
I'm catching you in the UK, so it's 1 hour less. It's 4:10 in the afternoon.
It is.
Why did you join a meeting in endoscopy? What can you do for the companies in the room today?
Well, Photonics are a company who focus on packaging, as you said, packaging the light sources. So we usually are involved in the front end, or one end of the endoscope. Let's call it the back end, actually. And so there are several things. Yeah, I've been interested in optical coherence tomography for about 20 years, working in that area. And I think there was a mention that the hardware is all there and done, but actually there are some big problems. And for example, you put an OCT, you get OCT systems that are used with catheters or endoscopes, generally are spinning at thousands of RPM. So it was really interesting to see Mica, and because looking at the front and the forward scanning OCT head would be a great thing, because you don't really want things spinning at 1,000 RPM or more in your body. And also Yannick's talk. I'm going to talk to Ruth tomorrow. Actually on Friday, Yannick, because that's also really interesting. Because another thing is the cost of things. I mean, the technology is fantastic, and we talk about technology, and we're all technology people, but cost is key. And still, putting packaging things is often done either very hands-on or with a very expensive machine, which is usually meant for one job. So I think the 3D printing technique applied to packaging is going to be absolutely fantastic. So that's a really exciting technology.
That's a big compliment that he's so happy. Look at his smile. I also want
I'm happy because it's sunny here. The sun's coming in the window.
Another friend of mine is Axel Kasper from the giant Excelitas. Axel, thank you very much for joining this meeting today. What kind of collaborations are we going to do with Excelitas after this meeting?
So maybe I have to, can you hear me?
Loud and clear.
So maybe I have to first tell in what sense Excelitas is interested in endoscopy. So we are looking at endoscopy from various sides. So on the one hand, we are doing the LED light sources for endoscopic illumination. On the other hand, we have the swept lasers for endoscopic OCT, which is already used in cardiovascular OCT. And my main interest is the optic side of endoscopy. So Excelitas is almost a system integrator. We are doing up to complete endoscope systems for robotic surgery based on the chip on the tip principle, and we are already doing this in volume production. But what we are looking for is we want to understand what are the next clinical needs which go beyond stereo imaging of in robotic surgery. What's next? What is the next modality to come into this field? And is there a need to integrate OCT with endoscopes? There's a lot of scientific work already done on that, but we want to understand what is the clinical need, what are the next steps to a powerful robotic surgery product, and to be able to come up with proposals for our customers.
Everybody's
so
talking about
it's
OCT.
interesting to see the technology that is out there.
Everybody's talking about OCT, but in the meeting we had with medical doctors in Amsterdam in December, there was quite a lot of interest on hyperspectral imaging actually be integrated in endoscopes. I'm going to give the floor to a friend of mine, Henrik Fabricius from Delta Optical Thin Film. Henrik, how are you doing today?
It's quite interesting to follow this discussion. We don't ourselves do any optical coatings for endoscopes at the moment, but we are very, very well known for doing optical coatings, variable coatings for hyperspectral imaging. So some of our variable filters for hyperspectral imaging is used in satellites, and some are used in drones, and they are also present in a very well-known snapshot hyperspectral imaging system. We also know some of the companies who has been presenting here as our customers, because the variable filters are used in a lot of different systems. They are used as wavelength selectors for the supercontinuum laser. And they are also used in microscopes, in the laser scanning microscopes on the sensing side. The problem I see in relation to the subject that we discussed today is that the filters we do at the moment are quite big, and the endoscopes needs to be very small. And so the question is, could this hyperspectral thing, could it be that that the filter is used to filter the light that is sent into the endoscope? Could that be a kind of solution, or could it be that it needs to be a endoscope with a lens system where the sensor is at the back end of it? In that case, our solution with filters in front of the micro lens arrays and sensors is very compact.
I've seen your filters. Actually, I love your filters. Tunable, constantly tunable filters in almost every color. They look like a rainbow. They're fantastic. You can put them anywhere. So the idea is to actually find the collaboration with the micro-optics companies to be able to deposit this at the tip of the fiber. And I think if that's possible, you are in the business. You're going to love the next presentation. I'm going to go to my friend Yves Vertig from Luminous. I really love this company. Luminous is one of the key companies that we have in this segment. Yves, thank you very much for being with us this afternoon. The floor and the attention of everyone goes to you.
Hi, Jose. Nice to meet you for the first time, and nice to be on my first online meeting. So that's great. Lots of very good stuff that I seen here. So let me try to share my screen. Can you see it?
We can see it perfectly. The floor is yours.
All right, very good. So yes, Luminous has been involved in LEDs for quite some time, and I'd like to discuss it a little bit. So Luminous has been actually a spin-off of MIT in 2002, and we were a spin-off trying to develop photonic crystal-based LEDs. And we first actually focused our LED products on different markets. The very first market that we focused on was the rear projection TV market. We launched the light engine with Samsung, and the rear projection market, we all know that it went soft, and it was taken over by LCD TVs. But the technology that we developed for this market allowed us to really play in the endoscopy market early on. So we launched the first product in endoscopy market back in 2008, 2009, and that was based on a white LED, 10 watts. And the very first that we focused on was trying to match the fiber bundle, typically 5 to 7 millimeter fiber bundle. So for the first time, we have LEDs in 2008 that were able to compete against legacy solutions such as xenon lamps. And from then, we have been involved in endoscopy market for the past 12 years. And it's very exciting because in the past 12 years, we have been working on LED solution targeted towards this large fiber optics. And now we see more and more from a system maker a demand for more power, but to be matched in a very small fiber bundle, 1 to 3 millimeter. So we have been developing products, as I say, starting from white. We introduced UV LED, typically at 400 to 420 nanometer, that was based back in 2012. And that really allows us to do narrowband imaging with very selected endoscopy manufacturer at the time. We even launched in 2013 white LEDs that were the very first one that were 14 millimeter square emitting area circular emission to better match the fiber optic bundles that we were dealing with. And from then, in recent years, what we have been really focusing on is adding more wavelengths to this visible spectrum. So very specific wavelengths in addition to the legacy RGB LEDs. So what we are trying to do more and more is work with system manufacturers, work with light engine makers in order to really find the new wavelengths that are being used for new diagnostic that system maker and clinical researchers are trying to bring to this new market. One exciting thing that we have been doing in 2020 is really launch IR LEDs that are targeted for this specific market. We introduced a line of products that take advantage of this new diagnostic tools such as ICG imaging, and we develop lights that match this specific diagnostic. So the need going forward is more and more power. So we are already an outlier in the LED world, where we have from early on developed LED solutions that are very high power. So typically the LEDs that we have here, they range from 50 to 100 watts of electrical power and deliver anywhere between 5 and 20 plus watts of optical power. So that's the type of LEDs that can rival with, as I say, the xenon lamp-based solution, but as well as a laser solution in some specific application. So in terms of this endoscopy market, which is not just one market for us, I mean, it's really what we call a fiber coupling LED market. So that encompasses microscopy, life science, machine vision, instrumentation application. We have now a host of LEDs, more than 10 different type of products that are very well matched to these large fiber bundles. So to give you some example in terms of whites, we have standard LEDs that are really focused at delivering a maximum lumen output, but other ones are more in terms of quality of light, looking at ICRI solution that are required in some very specific market. As I said, more and more we are moving into UV. We have LEDs that are targeted to UVC now, looking into 280 nanometer. And I'm wondering if down the line we will have UVC LEDs that will be used for disinfection in endoscopy application, which would be great. And also moving up the chain towards closer to 1 micron of emission. One of the key advantages of LEDs and I would say laser at the same time compared to a legacy solution is really this dynamic range that you can have. So these LEDs, they can be driven from a very low current, 1 amp, all the way to 36 amps or more. And the key thing here is from a system manufacturer, what is very important is regardless of the current that you drive, the image has to be of the same quality, which means that there are constraints that are being placed on a LED maker in terms of making sure that the wavelength of emission is not affected by the drive current. And that's very challenging. More and more also we are looking at narrowband imaging, so meaning trying to have an emission that is as narrow as possible and that provides some value proposition compared to legacy lamp solution. So if we go in more details, and if I looked at the high power LEDs for this specific market, what is the need of this market? So obviously, this is a market where you need to interface to a fiber optics. So any type of lens on top of a LED is not something that you seek. So we are developing solution where we are what we call windowless. So the emission of the LEDs is directly into air. You can couple a fiber optic directly in contact with the LEDs, or you can use secondary optics in order to match as much as possible to the fiber optics. All of these LEDs, they have to be controlled in temperature. So that's what we integrate a thermistor in all of our LEDs. They are directly in contact with copper substrate. And all of this small improvement will allow us to really tailor these LEDs to this very specific demanding market. Without going into details, it goes down to the chip level where we have a very efficient thermal management and photon extraction that are in place in order to really optimize these LEDs as much as possible. So based on this technology, we are right now in the process of developing the next generation of LEDs. First generation that you can see here has been in production for the past 10 plus years. And we are very excited about working with our system partner to really develop a next generation that will allow the LED to be even smaller, being able to be driven at a higher current, both in CW and PWM mode, and at the same time deliver the same power output. So very excited to see where the industry is going. try to work with system manufacturer partners in terms of optics, in terms of thermal, in terms of mechanical partners. It's really by combining all of this partnership that we can really go in the direction that the overall industry is demanding. Thanks for having me.
Thank you so much for this very nice talk. Very interesting. Let me see first before I start if there is any questions. Otherwise, what kind of collaborations are you open for? In another term, the epic question, what are you looking for? Or what can they do for you?
Well, again, we are looking at two levels of cooperation. So we are working from a system manufacturer to have a better understanding of where the direction of the market, where this market is going. We will see it going in multiple directions. One thing that I didn't mention here, there's a demand for disposable endoscope, and what does it mean for a lighting company? Does a solution like micro LEDs is an attractive solution or not? And at the other end of the spectrum, we see the need for more and more power density. So people are asking for the same power in a smaller emission area. They're asking for new wavelengths, as I say. So from this system manufacturer, we need to have this information. In terms of partnership, we always work with different type of partnership. People who are working on optical coating, people who are doing mechanical packaging, and also all the thermal aspects. So the thermal aspect is very important, and we are looking for companies that can provide thermal material that we can integrate in our LEDs.
Great. I love job shopping list. Wilfred.
Oh, yes, I have a question. You mentioned it already as one of the requests. So we're looking desperately for LEDs, for white LEDs with a very small étendue. That means a very small surface area, and at the same time, it doesn't have to be Lambertian emitter. So we want a small angular spectrum at the small surface, but white light. And because we do imaging optics for white LEDs, for microprojectors, for automotive applications. And the problem there is a light source, which limits the image quality on the projecting side. So, this is an optical étendue problem. And if we could have these small LEDs, this would be a breakthrough in the market.
Yeah, well, so we do, as I said, we offer LEDs that are without any lens on top of the LEDs, which basically solve the problem of the étendue, and we offer them in different type of emission area. So we are working from, as I have shown in this slide, there are some LEDs that have 14 millimeters square of emission area, and we have some which are sub-millimeter square. So very wide range, and we are working actively more and more into this automotive market that is also a very important market.
Lars. So we could get in touch.
Sure.
Thank you so much. Lars, you had a comment?
Yeah, thank you for a very, very nice presentation, and salute to your products, because I've used your diodes for a number of LED based endoscopes. But my one big problem with your product is that your format is square, or rather rectangular. So whenever I try to image your chip onto a round fiber, I'm always gonna choose between underfilling or overfilling.
Well, that's something that people have complained. So we are not always square. Actually, we sell these LEDs a lot for video projection system, matching them with DLP, and in that case, you are rectangular. But to answer your question, yes, we have some LEDs that are round LEDs. So that's LEDs that we have developed specifically for entertainment market. We have been thinking hard about developing LEDs that are circular for fiber coupling application or endoscopy application. There are some potential issues, but we are more than willing to work with specific requirements, and that's definitely doable.
Thank you so much. There is one guest that I would like to introduce, Seya from HOYA. Can you tell us a brief introduction of what you do?
Okay, thank you, Sarah. I'm Seya from HOYA, and we are a filter supplier for various market. And yeah, we have a lot of experience for the endoscopy market. And recently, we have also support to develop one customer to make biomarker inside the body and to irradiate the tumor. And divide the light source, and only the tumor gets irradiated. And yeah, such kind of experience we have, and we would like to support a lot of customers and also members and EPIC. And yeah, we are open to discuss, and yeah, we are ready to offer our best solution.
Thank you so much. Now we come to one of the most important challenges in this field, the coating part. And I'm very happy to have the next talk from Alex from ACM and Actor. Alex, how are you doing? You can unmute and just start.
Thank you for your introduction. I'm doing fine until
Looking
now.
Forward to your talk.
Until now, very interesting talks. I am trying to share my screen. And I hope you
very
can
nice.
see
Yes.
it properly. So thanks again. We are Actar and we are doing coatings, but the other coatings, we are doing very black, deep black coatings and coated foils to suppress stray light or to absorb laser power, or also to create high emissivity surfaces. So it has nothing to do with anti-reflection coatings or with filter coatings that our other colleagues from, for example, HOYA or Optics Balsers do. We are specialized in high absorbance coatings for photonic systems. So I am the CEO of ACM, and we are the German and European subsidiary of Actar. And Actar is an Israeli technology company. We serve every market using photonic technology because everyone that deals with light is always to deal with light that he doesn't want to have in the system. And the medical industry is one important market that we serve. Epic presentations, especially here in the online meetings, are always about questioning ourselves and also questioning our audience. So that's why I have structured my slides into 3 questions. Why should you use black coatings in endoscopy, and how can you use them? How can you utilize them? And the last slide, absolutely, for the epic questions. What can we do for you and what can you do for us? So why should you use ultra black coatings for endoscopy? And I'm not only talking about the legacy technology, but also about new technologies. It's about improving image quality by suppressing or absorbing scattered light in the system. The smaller the elements get, the more problematic scattered light gets. You also want to increase the sensitivity and the contrast on the sensor side by reducing the noise of the background signal. And another point is you want to work with reliable and harmless materials, and our coating is absolutely inorganic. It's biocompatible and cytotoxicity tested and RoHS compliant. So here you are absolutely on the safe side. Another advantage is you can bring our coating into every stage of the product life cycle into working. So you can take a existing, sorry, I don't know where this comes from. You can take it into an existing system to enhance the performance, but you can also bring it into new developments and try to reduce the complexity or the number of components that are typically used to suppress dry light, like apertures and lens housings. I don't know. Do you see the screen something? I don't know where it comes from.
Yeah, don't worry about it.
Okay. Okay. Next question, important question is how can you use it? How can you bring it to your products? How can you utilize our black coatings? And we have so the process is a vacuum deposition where we apply a composite of metal and metal oxides on the substrate. And we do this either as a direct coating, so we apply the coating, the ultra black coating, on discrete parts. We are not limited to size, speaking of endoscopic systems. So the tiniest part we've coated on are below 1 millimeter in diameter. And the second option is to use a coated film substrate, a very thin film substrate from metal, from aluminum, from stainless steel, but also from polymer. Apply the coating and bring it into shape. Our coatings are suitable for a very broad wavelength range. And we do come from near infrared and infrared applications. And we have heard during these talks that working in the infrared, in the near infrared, is getting more and more important. So our coatings do work also not only in the infrared, but also in the infrared, starting in the UV, absorbing light in the UV, in the visible and in the infrared wavelength range. So we are ready to go for nearly any optical application. And in addition, our coatings do not have any autofluorescent signal. So you can also use it for like Raman spectroscopy applications. We can coat on any vacuum compatible material, so on close to any medical grade materials. We typically, for the endoscopy market, we coat on stainless steel, optomechanics. We have seen the very nice lens design with 10 lenses by FISPA. There you've also seen a huge number of optomechanical parts, and these are the typical parts where we apply our coating on to suppress this stray light. Our coatings are very thin in comparison with other technologies, and they do have a very reliable thickness and are conformal to sharp edges. And apertures, field apertures for endoscopes are a very typical application where our coatings are used. Yeah, that's maybe just a short introduction about what we can do. And now let's go into the epic questions. What can we do for you and what can you do for us? So I try to explain what we are doing. So very black absorbing coatings to suppress dry light in also endoscopic systems. We are making high performance optical systems possible. We can do this as a service. So you supply optomechanic parts to us where we apply the coating, but we also do, especially for the medical industry, for endoscopy systems, we do complete manufacturing, including machining of units, laser cutting, CNC machining of components, and also the coating. And we also produce ultra black foil. So this is what we can do for you. and what can you do for us? So we are always looking into new application ideas. So not new applications for the photonic, but new applications for our coatings. Maybe applications that are not related to stray light suppression, but for example, related to other applications. For example, we had applications like high contrast calibrating targets that we have realized for customers, or even customers coming from the jewelry industry that need a perfectly black coated something. We are always looking to test and to qualify our coatings in demanding conditions. Here we are always looking for a collaboration and also R&D collaboration in projects. If you come from the coating technology side, always also looking for improving our coating performance, for example, the mechanical resistance. So here we go. I'm looking forward to the discussion.
Thank you so much for the very nice talk. This is the darkest black around, and these applications are very large, large field of applications also for space industry and all kind of imaging. Very, very interesting. Let me see first if we have questions in the room. Thank you for making nice, epic questions, made it easy, my job at the moment. Thank you so much. So if we don't
Peter has a question. Peter?
Okay, Peter, please.
Hi, I just want to ask, is there any guidelines as to what kind of parts that you can coat? And like, for example, if I want to coat an inside of a very small part, is that doable? And what is the limitations?
So coating inside of parts is our business, because the optical path is always inside of something. So coating inside a part is our business. It's a bit limited by the complexity of the shape inside of the part, and also of the relation between the diameter, the open diameter, and the depth of the part. But coating complex shapes inside, that's what we are doing.
Okay, so the second question, I have a follow-up question.
Of course.
When I want to do parts with you, you do it on a batch basis, and how much volume can you handle on the single batch?
It's depending on the size of your part, because so it's
very small parts, maybe 1 by 2 mm.
Well, I don't know how many pieces fitting in the machine, but this is a very tiny part. A lot of parts fitting in the machine. So we start at quantity 1 for prototyping projects, and we handle a high quantity for serial production. So 10,000s of units, 100,000s of units. It's no problem for our technology. We are very flexible with that.
I think definitely he can solve your problem, because I know the problem of Peter. This is obviously a huge room for collaboration. Another question is coming from Ralph, all the way from beautiful Finland.
Yes. Yeah, when you were talking about ultra black coatings for foils, what are the manufacturing volumes of foils that you can realize? I'm thinking of many cases where in the printed hybrid electronics world, also for photonics integration on roll-to-roll processes, we would really, really like to have coatings of foils that we can put around components that are really ultra black and that are absorbing all the stray light. Have you worked with roll-to-roll applications before? Can we buy your rolls by the truckload, basically?
You're most welcome. So our film coating technology is a roll-to-roll process. So it's the same coating process like for the batch, for the direct coating, but it's a roll-to-roll machine. So we coat on running meters on the film substrate. We are kind of limited in the width of the foil, but we can coat on running meters. We have, for example, a standard material where we coat on a polyimide substrate, a Kapton film, 75 or 50 micrometers thick. We can deliver it maybe not a truckload tomorrow, but during the next weeks.
Okay. Yeah, I don't think truckloads will be needed. I think it's always very specific small parts that need to be coated. But you offer the coating as a service. You don't sell the inks or at all, right?
Unfortunately, there is no ink, so it's a vacuum deposition process. So
okay, all right.
We cannot deliver any spray or something. That's not our business. So it's a vacuum deposition process.
All right. Okay. Thanks
Excellent.
a lot.
More emails for you, Jose. More introductions to be done in here. That's always good. There's more. We will hear more about coating from a very good EPIC friend. You've been present in almost all EPIC meetings. We have optic pulsars. It's either you or someone from your team. Hi, how are you doing?
Hello, this is Armin from Optics Pulsars, right.
We're looking forward to your talk, Armin.
So I just share my screen.
Yes, please. We don't have it yet.
Okay.
It's on the bottom. You will find in green, share screen.
So you see now screen number 1?
No, you have to click on it.
Sorry, any issues? So I do it again, sorry.
Yes, I'm sure you can manage. You managed to
Maybe
make
we
the
can
best
introduce-
coatings. So I think it's really great that you can. In the meantime, there is a company that I love in the, oh no, we're here and we are in business. The floor and the attention of everyone goes to your coatings, goes to you.
So I think it has worked now. You can all see it.
Yes, thank you.
Okay. So thanks for this great opportunity to show you teams our optics pulsars contribution to the endoscopy market. And first I want to start like saying thanks for the nice presentation so far. This was really delighting. I'm working in optics pulsars as a sales manager. And to start here. So company overview, maybe I start with a few information on optics pulsars. The company was founded in 1946, so optics pulsars is kind of a pioneer in thin film, optical thin film technology. Today we are about 500 people, work from 3 production sites that is headquartered by Liechtenstein with R&D and production, the same R&D and production in Jena in Germany, and also a mass production for high volume business in Asia, in Malaysia, Penang. So there's a worldwide presence. Yeah, we are an optical thin film company, so our products is thin films and optical components. We work in quite broad spread market within the industry. So there's a lot of market segments. This is the way we divide our business in life science industry, consumer lighting, space, and also endoscopy is an important market for us. Looking to a coating technologies overview, we drive both an evaporation platform consisting of a E-beam evaporation and also ion-assisted evaporation. Looking to the endoscopy coatings we do, this is mainly used for the traditional AR coatings on lenses, also a lot of other products, but ARs still play a very big role with regard to volumes. We drive also a sputtering platform consisting of a magnetron sputter deposition. This is the largest machines we have. You see it also here in the picture. A plasma assisted reactive magnetron sputtering. This is the platform we do quite high sophisticated coatings, which consist of, say, over 100 up to several hundred layers that can go up to above 50 micron thickness. So quite complicated, complex coatings. and as well IBS, which we mainly use for laser. But this platform and the evaporation we use for the endoscopy application, the sputtering system, for example, for ICG filters. This is core processes we drive in the thin film production, and that shows very nice the big role that plays also in the endoscopy business. So what we do is we handle a lot of customer value when we coat these parts. So looking to lenses and AR coatings, which is still the traditional big mass business we do here, there's big volume, big value we handle for customer, and to get a good production yield and stable process is core. This is really a key in this business, and those processes need to work well. So we have a very experienced team in this substrate processing, in customer substrates processing. When you look to handling or cleaning that we do automated, tooling is very important for those lenses, and also visual inspection. And all these processes have a long tradition, are installed in a close cooperation with the customer to work smoothly for a mutual success in that business and with the customer. Going to the products we mainly have in the endoscopy field. This is the broadband AR coatings, what I mentioned, the lens business. Also another variety of AR coatings like single wavelengths AR coatings. AR and sapphire windows. So the distal and proximal windows of sapphire are coated with AR. And also for those windows, we apply a gold coating that can be soldered. So we call it GLOT. This is a company, artificial name. So it's a gold coating that enables glass to be soldered. And we had the discussion about cleaning. So with a soldered window, the autoclave process, it was mentioned, it's maybe not always given, but such harsh environments that withstands very well. Even the steam pressure, which is a harsh request in that, and it's quite a good hermetic sealing and long life. Yeah, high absorbic black chrome coatings we do as well. They can be structured, etched, or in a photolithography process applied. That leads to very sharp edges, high resolution in the in that field. Mirror coatings, for example, on prisms, in terms of front mirror coatings or rear surface mirror coatings. Low temperature coatings, we had the questions on maybe materials like plastics, or even if we look to temperature sensitive substrates or achromatic substrates, there such processes work proper. And away from that very traditional product field, look into newer applications. We also do edge filters for ICG application, such as band pass, short pass, long pass filters, notch or beam splitter. yeah, look into the benefits of the edge filters in ICG or even new emerging application like hyperspectral imaging application. So there is the magnetron sputter process, the process we use here, because these coatings often go to quite complex, thick layer systems that have several tens of microns in thickness and go over 100 layers. So that leads to highly precise cutoff and cut-on wavelengths. The spectral edges are very steep. To have a good excitation and emission signal separation. The out-of-band blocking is very important. There we go to where it's necessary to OD6 and even beyond. Transmission values are very high in pass. Yeah, and we do this with a very experienced team because this is application we have in our company even apart from the endoscopy field. So we do hyperspectral imaging application, maybe, for example, in space application. This has a great history in our Jena operation, where they do hyperspectral imaging filters for Earth observation in satellite applications, or even ICG application. We have in fluorescence microscopy or also Raman spectroscopy. So this these activities here are somehow related to the requests that we see in endoscopy as well. And this experience that has built up is very beneficial. Yeah, those filter curves, just to give an expression on the ICG bandpass filter curve. So this is an excitation filter. You see a dashed line, which is a production versus the design curve. There's no real difference in between. You see very steep slopes that enable to put the emission characteristic and the filter very close to the detection. So the cut-off filter at around 800 nanometer is very close to the emission curve. Look into here. Yeah, whilst the transmission is very high, it's even beyond the 95, which I showed before in the value. This is very close to 100, and you see this is measurement curves. So this is real low loss processes and low scattering processes, which enable a very high signal. Outside the in-band area, this is where we achieve the very deep blocking, where essential, especially in the emission detection path, where the signal is much lower than the excitation field. You need to have a good suppression of the noise, of the not wanted light, and there an OD6 filter is no problem, that can be achieved and often requested.
Thank you so much, Armin. We will be very happy to connect you with all the people present in here. And yeah. Before moving on, I would really like to see who have a question for you.
Yeah, it's even finished. Yeah, that was the last.
Okay, you stopped the sharing.
We have lots of opportunities in the room, so I want to give the final remarks, but I don't want to do it because I'm crap at it. I'm going to do the style. I get my members to it. So I want to hear from first Sensor, who was here the whole time, was very quiet, and I want to understand. Christian, thank you very much for joining this interesting and interactive meeting so far. What do you take away? What kind of collaborations, cooperations we can do afterwards? Christian, I think you are muted. We cannot hear you right now.
I do it now. Maybe
yes.
now it's fine. Good.
It's perfect.
Thank you, Jose, for the invitation. It was a very nice meeting and very interesting presentations at all. At first, I have no impressions for all the coatings and all the technical needs what are on the market with the endoscopy. What we are doing, and especially with the first Sensor crew, what's very interesting for us for the meeting is that we have a lot of requests for disposable endoscopes. Very small endoscopes with 1.1 square meters and with the sensor inside and combine some sensors. And this is a very interesting topic maybe for new talks for the future. And for that here, we are looking for some companies for collaborations. We have several projects are running, but it's a very small and very tiny products. And we are specialized now here for the combination of the optics, the electronics, the cables, all this stuff. And it should be very interesting to have some new companies on the talk here to see if maybe for future projects.
Thank you very much. And you praised you said the magic word, looking for cooperation. So be ready. There will be quite a lot of introductions. We have a question from Nushatel from SUS Micro Optics, from a very good friend, Wilfred. What's in your mind? Yes, ask away. Don't worry.
Actually, I was first, I'd like to answer to first Sensor. So we are also in this market and as a component supplier, not as a system supplier. So it would be very interesting to talk to you about disposable endoscopes. And the question I had was more for Balzers Optics. I wonder what happens now with you becoming a part of Materion. Is that going to change anything for you? Are you accessing new markets, or I'm just curious?
Yeah, but this is a very new situation. It's 1 year old, and the Castle Authority release is outstanding. So in Q3, this will become real. You're absolutely right. We will be part of Materion, but from today's view, which is everything is brand new, we assume that the business will stay as it is, and look into how we will merge. It will be a very good fit to the Materion business. So far, we work in different wavelength areas, and we also work in different markets. So Optics Balzers is a very strong partner in the Europe business, and we cover application that is not given on the other side. So
it is of course obvious to me that at the end of the day, what you are doing now is really expanding the market outreach, adding a lot of potential materials to your capabilities. And I think in the next year, I expect a huge boom from Balzers. I love this company. I want to hear the final remarks from IMS. Nathan.
Hello, Jose. Thank you for giving me the mic. Well, what was very good for me to see during this meeting was that there are a lot of different companies that are able to supply a lot of different components, the LEDs, the optics from SUS Micro Optics, the coatings from Actar, and it all comes together at companies like Excelitas. What for me is very interesting in this case is that there was also spoken about single-use endoscopes, and that maybe being some kind of the future for the endoscopes. And what I would like to say about that is that there was also mentioned that it's still a high cost for these endoscopes. And part of the solution might, of course, be manufacturing in higher and higher volumes. That's also where IMS comes in. My company is a machine builder. We are very experienced in the medical world. So I have a product here that some of you might know. I hope it's visible.
Yes.
That is used in the medical world. So we have some experience there with building machines for the assembly of these kind of products. We also do that in smartphones. We built a lot of micro lens machines for that, and we also have aligning capabilities like you can see behind me. So what I would be very interested in is the meeting that Mr. Kempf also proposed for the single-use endoscopes, and I would be very interested to also get in touch with companies that think, well, this might be a market that is ready for high volume in the next coming years, and please contact us for your machines.
And my friend Dennis has the honor of closing this great meeting. Dennis, how are you? What is your learning and what kind of cooperations are you going to start after this?
Thank you very much. This has been a great meeting. So I just wanted to say a few words on what I've done. I'm a good person to summarize. I've been involved in endoscope design for more than 25 years. I'm the founder and longtime president of Lighthouse Imaging Corporation. Since I saw that, I formed Liner Optics to help other companies coordinate their endoscope development. So I hope I can be useful for that. In addition, I'm the project leader for many of the ISO standards for endoscopes. So anybody, and I know many of the people at the meeting already, having been old and been in this business for so long, please contact me to help you strategize your endoscope products or for standards for ISO in endoscopes.
Thank you for raising that point. Actually, we are working now, Epic, with the CEO of Asphericon, with Sven Kiotke. He's now the chairman for the ISO DIN cooperation for the standards, and we are communicating those standards because I can tell you one thing, Dennis, we don't understand what is written in those standards. And I think there is a need for communicating this to the optics manufacturers in Europe, because I can tell you one thing, we have the best optics, especially micro optics, worldwide right now manufactured in Europe, and we don't understand, and I'm working with DIN and Asphericon to make sure we translate this. Thank you for raising that. I can tell you one thing, I learned a lot, but most important, I realized I have a lot of work connecting a lot of companies. As many of you know, I have a disease, which is I take a lot of notes. I love taking notes. This is what I wrote after this meeting. The first thing, I realized that the trend is miniaturization and chip on tip. The biggest need seems to be, and I think on that, EndoMapper really put it on the right track because their end users are really telling them that data analysis is still there, and we need to address that in a different topic. Main opportunity trend seems to be, for me, the addition of micro optics at the end of the fiber, and on that, I think nanoscribe, multiphoton, they have really, really great technology for addressing that market. I see a great opportunity for them. The trend, disposable endoscopes. And I think people say the biggest challenge is cost. I don't believe it, because when I see the presentation from Slava and I see what the guy from GBF told us, the market is high enough to go into mass production. Cost should not be the issue. The next big deal, I love the haptic feedback from Technobis and the idea of having all the companies making FPGs for addressing that particular market, because this is a very standard, mature technology ready for this application. Laser illumination, broadband. We need broadband. And on that, the SK lasers from NKT are really, really the key solution. And they know, because of course they are already introducing them to this market. In the LED illumination, we have seen the same trend, roadmap, but here we really look at the UV LEDs, perhaps of purification applications, and the white LEDs to illuminate the whole region. Functionality, OCT, we talk a lot about OCT. People mention hyperspectral imaging, and I noticed from the doctor's side that there is an interest actually on having hyperspectral imaging. Whether it can be integrated or not is a different issue. And specialty fiber solutions, that was the highlight of the meeting. We had really all the different specialty manufacturing solutions in different market segments. The idea here is that we are available from UV all the way to mid-infrared. I love the presentation that we had from GLOphotonics. I love the comments from OFS. Of course, Photonics was fantastic. We just need the qualification. I need the system integrators. And on that, I would like to say one thing. I'm going to direct to the four of you, to Stryker, to Olympus, to Richard Wolf, and to Schott. We are not eating anyone here. We just want to talk to you. I know you have been following this. I know, because you are sending me WhatsApps. I know you want to have introductions, but the meeting is much better if the four of you are in the room. So the next time I want the four of you here telling us exactly what you want, because of course we understand that this is a very secretive market. We understand that everybody doesn't want to talk. We're going to make the introductions in private, but I don't like it. I don't like private. I like communication, and that's why I have so much fun at this job. Until the next time, continue being epic. I'm so sorry we're out of time. 42 minutes late, Sana. What did we do? See you soon. Take care. Bye-bye.
Thank you, everybody. Thank you for your patience. Bye.